In the next several chapters of this course, we're going to be going over the syntax of JavaScript. This is not going to be a complete coverage of every single element of JavaScript syntax because the goal here is to allow you to get conversant in JavaScript. Just as with any other spoken language, you won't be totally fluent in a matter of a few hours. But you will be able to read code like this, which has some comments and some actual functionality, and you'll be able to make sense of it. You'll understand control structures. You'll understand the different kinds of data types that are available, and you'll know how to use variables. You'll understand comments in Whitespace and generally have a pretty solid understanding of how the language is put together, enough that you can start working with it on your own. That's the goal. Not perfect fluency, but to become conversant. Programming languages are a lot like human spoken languages. You need to learn the grammar in order to be able to use it, but that's not enough to become totally fluent. You need to put in a lot of time reading the language, writing the language, generally using it in whatever way you want to. With human spoken languages, of course, you could simply speak it with your voice and get a lot of use from it. But with JavaScript, you need to be able to read and write it. And after going through this course, you should be able to read and write code and begin to do what you need to do using JavaScript. So let's get started. Programming languages go through revisions over time, just like apps do. Bugs are fixed, new features are added. In JavaScript, the feature additions are what people tend to get excited about, no surprise probably. Let's talk briefly about the versions of JavaScript that you'll hear about. Though JavaScript is the language's most commonly used name, the body that maintains its standards is ECMA International, so versions are named accordingly. ECMAScript 5, or ES5, is the version that runs on all modern web browsers, released since 2012 or so. There are older versions, of course, but this one is the general baseline, and the one that most people mean when they think of mere JavaScript. Most of what we'll be talking about in this course will be ES5. The other most commonly discussed version is the one after ES5, which is sometimes called ES6 and officially is ECMAScript 2015. There are a lot of new features in this version, and browser support is pretty good, but not good enough that web developers can use it directly in browsers safely. As you might guess, there are other newer versions as well, finalized pretty much every year, that continually add more features and make the language feel new and shiny all over again. But for the most part, ES5 and ES6 still make up the lion's share of JavaScript in common use. If you want to use the features of a newer version of JavaScript without sacrificing compatibility, there exist tools called transpilers, which can take your newer, less compatible JavaScript and convert it into ES5 so it can run on most web browsers or whatever else you're targeting. The most popular of these is called Babel, available at babeljs.io. Because we're just getting our feet wet in this course, we'll be sticking to ES5. All subsequent versions add on to it, so what you're learning is still useful and foundational, and you won't have to worry about compatibility or the need for extra tools to use it. When you're beginning to work with JavaScript, it's important to start trying it out as soon as possible. Fortunately, there are lots of easy options for doing this. In this video, we're going to look at a couple of the easiest ways: JavaScript consoles in web browsers and the Node.js console. We'll start with web browsers, since everyone has a web browser they use, and as far as I know, every single browser has a JavaScript console. Let's look at the console in Chrome first. In the Chrome menu, I can open up More Tools and open the Developer Tools. On a Mac, you can also open it with Command-Option-I. On Windows, it's Control-Alt-I. And here's the Console tab, which has a JavaScript console. So I can type 2 + 2, hit Return, and it executes, giving me back 4. That's JavaScript. A couple of notes. The console only shows one executable line at a time normally, but you can hit Shift-Return to get more lines if you need them. Wherever your cursor is, if you just hit Return, whatever you've typed should execute. The way you activate the console varies from browser to browser, so let's take a quick tour of the major ones to see how to get a JavaScript console open. We've already seen Chrome, so let's take a look at Firefox, Safari, and Microsoft Edge. Over here in Firefox, I can use the same key combination as in Chrome, Command-Option-I. That will open the developer tools for me, and I have a similar set of tools, including a JavaScript console. So I'll type 2 + 2 here, hit Return, and it works. You can also find this up in the Firefox menu under Web Developer and Toggle Tools. We'll look at Safari next. Safari is a little different. It requires a little bit of configuration first, if you haven't done this before. So you can open the Safari preferences, go to the Advanced tab, and check Show Develop menu in the menu bar. Once you've done that, the key combination that we've used already will work, Command-Option-I, which opens or closes the web inspector. There's also a separate command that will take you straight to the JavaScript console. Once I'm here, I can type 2 + 2 again, and I get back 4. Finally, let's look at Microsoft Edge. I have that running over here on browserstack.com, which lets me run Windows browsers from my Mac. Microsoft's developer tools are called the F12 developer tools, so named because you can open them using F12 on your keyboard. When you do that, everything looks very similar. Here's the JavaScript console tab. I can type 2 + 2, get back 4. This is over on the side right now. Most of these tools let you change their location using similar controls to this. I'm going to keep this over on the side so it's out of the way of the browser stack controls over here. And you can hit F12 again. It appears to shrink it, but then also makes it go away. If you're interested in using JavaScript for backend development, you'll probably want to look at Node.js, which is installed as a command line utility called Node. You can get it from nodejs.org. I have it installed here on my Mac, and so in the terminal app, I can run it with no options, just type node, and it immediately drops me into a REPL, which is like a JavaScript console. It's called a read, evaluate, print loop, where you can play with it just like you would in a browser. Let's try typing 2 + 2, and we get back 4. It works just the same for our purposes, and if this is the direction you plan to take in your journey with the language, you might as well install it and start playing with it here instead of in a browser. One nice thing about Node is that it detects when something you're typing could extend to multiple lines the way we normally would write it. So if I start defining a function, let's call this function my function. I know you don't know what this means yet, but just bear with me. Normally at this point, I would hit return, and if I were typing this in a browser console, I'd probably get a syntax error because it's on one line and I need more. But Node puts in this ellipse to indicate that it knows I want to type more stuff here. So Node knows what I'm doing. It gives me the chance to write more before it executes what I've typed. It's pretty neat. And I can hit Control-D to get out of this. Now you've seen some of the possibilities for where to play around with JavaScript. I'm expecting most of you will probably use web browsers at first, but Node is available to you as well. In this video, I'm going to extol the virtues of a good text editor, give you some reasons why you might actually want to have one in your toolkit, whatever your level of experience. If you're a web designer coming to JavaScript, you might have an editor you like for HTML and CSS, and that editor will probably be great for JavaScript as well. I've been teaching new developers for years, and I'm continually impressed with how many high-quality, free editors are available now. We'll mostly talk about the features that are noticeable when you're working on very small projects with a small number of files and not a lot of code. Editors can, of course, work with projects including thousands of files, but they're great for the small things you'll be working on when you start out as well. The first thing everyone notices when using a code editor is syntax highlighting. The editor uses colors and styles to mark the different kinds of code to help us know what we're looking at a glance. This makes the difference between something like this, which has syntax highlighting, and something like this, which doesn't. This editor has no awareness of code whatsoever, so there are little spell checking squiggles all over the place, and there's no color. It's just much harder to read and understand than this. Code completion is the next big one. Your editor saves you typing by giving you options for how to finish what you're typing based on what it knows about JavaScript and about the code and the files you're working on. So if I start to write the word function, this editor completes it for me. I can type my function, and then inside this function, I might start referring to a JavaScript array, and then I type a dot, and it gives me all kinds of other completions. Most editors these days have some awareness of complete projects and can draw on that knowledge to save you work. Editors can also help with the tedious parts of writing code, like managing special punctuation. JavaScript uses lots of parentheses, quotation marks, braces, and other punctuation that often come in pairs. Pretty much all of them will auto-type these for you. So if I type just a left curly brace, the right one is inserted for me automatically. And if I delete it, both of them go away as well. This works for parentheses and quote marks and all sorts of things. There are also other features to help you avoid common errors. Reformat code so it's more readable but still executes correctly, and more. Eventually, you might even step up to an integrated development environment, or IDE, which has all the features of a great editor, but also adds features to help professional and enthusiastic amateur programmers get their work done faster. I said there are lots of great options. Let's look at a few, all of which are available for macOS, Windows, and Linux. Visual Studio Code is from Microsoft. It's open source and free, and particularly JavaScript friendly. It's updated every month with lots of useful features and is very popular right now. It's the editor you'll see the most in this course. Sublime Text is another very popular editor. It's not free, but it can be used without payment for a long time. Before VS Code came along, this is the editor people talked about the most. Now, maybe it's a tie. Unlike most other current options, which are kind of like high-powered web apps running on your machine, Sublime is native, which makes it feel faster for some. Atom is from GitHub, free and open source, and another one a lot of people love. They're currently promoting their remote collaboration tools that let people work on the same file at the same time. Brackets is Adobe's free and open source offering. It's targeted at web designers with support for CS preprocessors out of the box, among other things, and of course it's great for JavaScript. If you're wondering what I use in my own daily work, I mostly work in PHP Storm, an IDE that supports JavaScript and PHP equally well, which is important for me. It's a little heavier to work with than these other editors. It takes a very little bit of configuration for any project I add to it, but once it's set up, I get so much useful help that I miss it every time I use another editor for serious work. As you grow in your skills as a JavaScript programmer, you might consider looking at WebStorm, the JavaScript-only IDE from the same company, JetBrains, and see if you like it. My recommendation for now is that you pick one of these editors, download it, and stick with it for at least a couple of weeks, learning its keyboard shortcuts and maybe even reading some documentation so you can really get the most out of it. You'll probably start to recognize the things you like and what you wish you could change. If the editor doesn't work in a way that feels natural to you, try another one. In this video, we're going to look at a few more helpful resources for learning JavaScript. As you're proceeding through this course, you may find that there are some things that aren't totally clear and that you might want to read a little bit more about. And so, here are a few resources to help you do that. First, a few books, many of which can be read online for free. Eloquent JavaScript by Marijn Haverbeke is available online for free. It's in its 3rd edition as of this recording, and it's a modern classic. It's not short, but it is excellent. Dr. Axel Roschmeyer has a series of JavaScript books available on his website, exploringjs.com, for free reading in your browser. He goes into tremendous depth, so I think of these as reference material more than books that I would read straight through. I always look to Dr. Roschmeyer's work when I need to understand some small detail. He leaves no stone unturned. His books cover all current and upcoming versions of JavaScript, so if you're wondering where JavaScript is going, look no further. Kyle Simpson has a series of books called You Don't Know JS. They're short, very readable, and excellent. Every book I've read has helped me reach a better understanding. You can read them for free on his GitHub site. He also has a series of excellent JavaScript video courses. Finally, for the books, there's JavaScript: The Good Parts by Douglas Crockford. It's a classic, older than the others here, and while it's pretty technical, no words are wasted, and I thought it was a pretty enjoyable tech book to read. I found it to be very helpful when I had a little bit of experience, but still was very much figuring out the basics. JavaScript has some eccentricities, and knowing which things are good to use and which are better to avoid is helpful. There's an unofficial companion site on GitHub called JavaScript: The Good Parts Notes, which has a constantly updated summary of what's in this book. I just found this when I was doing research for this course, and it looks great. Now, a few other online resources. I think the Mozilla Developer Network has the finest online reference material on JavaScript and other web technologies, HTML, CSS, and so forth. There's good example code for almost everything you might want to know about. CanIUse.com is a compendium of information on browser support for various features of JavaScript and other web technologies. When you're learning newer versions of JavaScript, it's helpful to have a place to look for whether that thing that you're learning can be used in the wild. Similarly, quirksmode.org has been around for a very long time in internet years and remains a great place to find out what works where. As you're working through this course or afterward, I'd encourage you to bookmark and refer to any or all of these. In this video, we're going to talk about variables and how to make them. So here we are in the Chrome JavaScript console. I've made it really big by typing command =, a whole bunch of times. And I've changed the dock settings so it's over on the left side, and I've pretty much minimized the entire rest of the regular browser window away so we can concentrate on the console. A variable, as you may have heard in math class, is a place to keep things that are unknown. That's one way of looking at it. For our purposes, you could think of a variable as a box with a label on it. We can label the box whatever we want and put pretty much whatever we want in there, and we end up with a convenient way to refer to some data. Remember that as a programmer, you're in charge. The computer is going to do just what you tell it to do. Nothing more, nothing less. You should assume the computer basically doesn't know anything unless you tell it something. Variables are an important part of how we do this. In the course of programming, we're dealing with a lot of unknowns, at least a lot of things that are unknown at first. We then use variables to accumulate the knowledge we need to accomplish whatever the goals of our program are. Here's an example. Say we want to write a function that's going to let someone draw a line on screen. Some of the things we don't know at first are the points where the line will start and end. We could have variables for those points and refer to them later by name when it comes time to draw the line. Okay, so that's the theory. Here's how it works. If we were approaching this the way you'd approach it in math class, you'd have variables called things like x. That's enough to create a variable, but it's an empty box right now. To give this variable x a value, we add a space, then an equals sign, and then we give it a value. So we could type 32. And we end every line in JavaScript programming with a semicolon if we're being good. And by good, I mean JavaScript doesn't require it, but semicolons help avoid confusion. What I've done here is called assigning a value to a variable. I'm assigning the value of 32 to the variable x. So now in the console, I hit return, and what I've just typed is executed by the browser. Now nothing here happens except the assignment. I get back the value of 32 in this case. But in the console, I can type the name of the variable I just created again, and do nothing else except end the line with a semicolon, and I get back the value I just assigned. And in Chrome, it actually preemptively executes this for me and gives me a little preview of what will happen if I were to execute this. So I hit return and there's 32 again. Calling things x is something that gets a lot of complaints in math classes, and we can certainly do better in our programs. Variables can be named almost anything that starts with a letter, underscore, or $sign. So I can create a variable called where am I? And set it to Santa Barbara, California, more or less. The part in quotes is a string, which we'll get to later, but that's how you store things like words or sentences. Now that I've stored a couple of variables, I can see their values, and the JavaScript console now knows about my variables and will start to complete the names for me if I start to type them, like this. Neat! I can also keep the label, but change what's in the box. So I can just do the assignment again with an equals sign, and change x to 45. And I can change where am I? I start to type this, and then I can complete it by hitting tab, an equals sign. And again, Chrome is previewing what's actually in there right now. I can change it to Los Angeles. Or I could change it to 75. I did this by hitting up from a blank line to get the last thing that I typed. So where am I? Set that to 75. I can set it to whatever I want. Now, of course, saying where I am is 75 doesn't make sense in real-world logical terms, but JavaScript doesn't care what I assign in there. We'll have a short digression on what that means later. So far, I've been assigning variables just by typing the names. I can also type the keyword var to create variables. Generally speaking, in actual code outside the console, this is what you'll do. So we'll do it here. I'm going to create several variables at once, and I'll start by using the var keyword. And then I'm going to create a few monsters. So we'll say monster1 equals Grover. Now I'll type a comma. Monster2 is Cookie Monster. Monster3 is Animal. And that with a semicolon. This just saves me a little bit of typing without having to do all of these on separate lines. If I type each variable's name and hit return, I get exactly what I put in. A couple more details. Your variables can be named almost anything you want, and I recommend you use names that are descriptive because programs aren't just for computers, they're for other humans to read as well. The computer isn't going to care what you call your variables for the most part, but humans definitely will. So make sure you name your variables something that indicates the sort of thing that they're actually going to contain. If I were writing a program dealing with how much it costs to ship a package, for example, I might have variables named things like package dimensions or tax rate, and so on. Starting a name with a lowercase letter and mashing on additional words with capital letters like this is called camel case. And it's a pretty common way to name things in JavaScript. There are a few words you can't use for your variable names because they're part of JavaScript itself. They're called reserved words. From what we've seen so far, you wouldn't be able to use var because JavaScript already claimed it. If you're curious, there's a list of reserved words available on the Mozilla JavaScript reference site. And of course, if you're using a nice code editor, it will highlight those words for you so you won't accidentally use them. Chrome highlights them in purple here, things like var or function. So that's an overview of variables, which are the way we give names to data. If we're thinking of JavaScript like a spoken language, they're sort of like nouns. In this video, we're going to look at strings. A string is character data, meaning things like sentences, words, single letters, numbers, or punctuation. Basically, it means anything between quote marks. So for example, I could say, this is a string. Chrome highlights in red for me. When you formulate a string like this, it's actually called a string literal. Literal here basically means you're making data of some type using the simplest notation possible. So making a string literal like this means I'm putting string data inside quote marks. There are other less convenient ways to make strings as well, but this is what we use 99% of the time. A string doesn't have to be a sentence. It can be a number inside quotes. So it's a string of 1, 2 instead of 12. These are two different things as far as JavaScript is concerned. 12 versus a string 12. You can make strings using these double quote characters. You can also make strings using single quote characters. This is also a string. Whichever you use, you need to begin and end the string using the same character. So I can't do this, a single quote at the beginning, double quote at the end. If I try and execute this, I get a syntax error. Doesn't work. Sometimes you're going to need to write a string that will have a quotation mark inside it. This comes up a lot if you're working with HTML in JavaScript. So if we're writing a piece of HTML like this, it works because I put single quotes at the beginning and the end with the attribute using double quotes. This is one of many times where syntax highlighting is helpful. Chrome offers some degree of this, but let's switch over to our code editor so we have a little more flexibility. I have here a blank file, and I'm going to use the default command, Command K, followed by typing M. This lets me set the language mode for the file. I'm going to type Java to get down to JavaScript and hit return. Now it knows that I'm trying to type some JavaScript. The color scheme that I have is going to show strings in red, so I can see whether a string is enclosed correctly. If it is, everything inside stays red. If not, it starts to turn black. It starts to give me little red squiggles. So I'll try that little snippet of HTML again. The double quotes contained in the single quotes works fine, and the opposite works as well. This is Joe's favorite string. You will at some point need to include quote marks of both kinds inside the string. Like say, this is Joe's favorite string. You can see that the color starts to change because I'm breaking the way that the string is delimited. To JavaScript, what I have here right now is a string, followed by some data in the middle that's going to make JavaScript mad, and then another string. To fix this, I need to use a backslash to do what's called escaping the string. So I'm going to put a backslash in front of each of these quotes that's supposed to be a part of the inside of this entire string. So for every quote mark that's causing trouble, I add that slash. Just to prove this works, I'm going to select this, copy it, and return to the browser, paste it in. There, it works. And it's printed without those backslash marks, which is a little bit confusing. I couldn't just copy this and re-execute it. It won't work. As you can see, this is turning black again. Backslashes let us do one more helpful thing, breaking strings up into multiple lines. So I'll switch back to my editor. And if I want to write another string called this is Joe's favorite string ever, I've got all these squiggly lines telling me that this is not working. But if I put a backslash on the end of each line, I'm putting a little extra space in there just to make it a little more readable, all the squiggles go away, the whole string is highlighted in red. And then I just end the string with the same kind of quote mark that I started it with. For something this short, it doesn't really matter, but when you need really long runs of text, this can be pretty helpful. So that's an overview of how to create strings, which are character data for things like sentences, words, and so forth. In this video, we're going to discover some things that JavaScript knows about strings and some tools we can use with them. Along with the data we've put in the quote marks, strings have a few tricks up their sleeve. We can access what are called properties and functions, also called methods, on any string. They're like a toolbox we can open to do things to our strings. A property is a single piece of data, like the length of a string, and a method is a bit of code to do something more involved, like convert a string to uppercase. So I can assign a string to a variable. Let's make one called myString. We'll say this is my string. Leave it alone. And now if I start to type my string and type a dot, I can see all kinds of information that's available on this string. So that includes the length, which you can see from this little preview is 34. I'll still hit return. So length is a property, and then a method would be, say, to convert this to uppercase. I start to type that, and it's completed. So I'll hit a right arrow to finish that off and type 2 parentheses to tell JavaScript that I want to execute that method and actually do it. And that returns the same string, but with the whole thing turned into uppercase. It doesn't change the original value. So if I type my string, hit a right arrow, hit return, my original string is unchanged. Interestingly, you can do this without variables too. JavaScript can take a string literal, like this is my string, and grant you access to the same properties and methods. It's much more common to do this with variables, but you'll occasionally see this usage as well. So I can see that this string is 17 characters long. All of JavaScript's built-in data types have properties and methods, and string has many, many more than we've covered here. But now you have some idea of what's available. In this video, we're going to talk about another of the basic types of data in JavaScript, the number. And we're also going to talk a little bit about math. You know what a number is. 12 is a number. Some programming languages have different types of numbers, like integers, floats, doubles, and so forth. All numbers in JavaScript are of the same type, called number. So 12 in JavaScript is the same thing as 12.0, which makes sense in terms of how we think of numbers in the real world. In programming, that's not always the case, but in JavaScript, it is. They're both the same thing. You can have numbers with lots and lots of decimal points. Let's just add a whole bunch of decimal points to this guy. And you can see that at a certain point, it starts to get cut off. Although you can see I put this in with, I don't know how many digits this is. It's a lot of digits. After the decimal point, JavaScript can't handle that much precision. You probably won't care about that most of the time unless you're getting into some pretty serious math. Along with regular numbers, of course, you can have negative numbers, all that sort of thing. Negative 12 works. JavaScript can also represent infinity if you need it. There's a built-in keyword called infinity with a capital letter. In JavaScript, infinity is any number that's larger than a very, very, very large upper bound. Odds are you won't run into it, but there is such a thing in JavaScript as infinity and even negative infinity. There's also this, which stands for not a number. And this is what you get when you try to do math, and the result, because of an error in your code most of the time, or for various other reasons, you can end up with something which is not a number. Be on the lookout for this if you're trying to do any kind of math and you're starting to get unexpected behaviors. If you assign a number to a variable, like I have here with my number, and I'll retype this and type a dot, you can see that there are methods available on numbers just like there are with strings, although I don't find myself using these quite as often as I do with strings. More interesting than the methods that numbers have is a built-in global object called math. We'll talk about objects later, but this is like another toolbox with functions and methods for doing things to numbers, like rounding, chopping off decimal points, taking square roots, and so forth. So if I type math capitalized like this, then a dot, that opens up the toolbox. And all of these methods and properties are shown. Next comes the method name, and then I can send the number into the toolbox with parentheses. So let's say I wanted to round a number. And so that rounds this number with all this decimal precision down to 12. Or if I change the decimal point to something over 0.5, it rounds upward. Math has a lot of useful functions when working with numbers, including one for generating a random number. Okay, technically pseudo-random, but good enough for our purpose. It's called math.random. This generates a random number between 0 and 1. If I type up, I can execute it again, and I get a different result every time. And you'll notice that the pre-execution that Chrome does gives me a different result than when I actually execute it later. It gives a different result every time, which is handy if you need some randomness in your program, like simulating the roll of a die or something like that. This is not nearly everything that pertains to numbers and math in JavaScript, but now we know a little bit about them and can recognize them in code. We'll see a little bit more in this course, and of course you can refer to the documentation on the Mozilla Developer Network for more. In this video, we're going to talk about Booleans, that is, true and false, and why Booleans matter to us. You may know from the way people talk about computers, sort of colloquially, that computers deal with ones and zeros, on and off, true and false, that sort of dichotomy. Boolean is a data type that can capture true or false for us. So in JavaScript, a Boolean is one of either true or false. They need to be spelled exactly like this, all lowercase and spelled correctly in order for JavaScript to know that you mean true and false. If you write true with a capital T, JavaScript is going to think you mean a variable by that name. Notice that it is not colored as a language keyword here in Chrome. Because it's so similar to that existing keyword, you would do really well to avoid naming any variable true. Likewise, all caps will not work either, or any combination of characters. Only all lowercase for both. I can set variables to true or false, like say button has been clicked equals false. And by doing so, I would say that this variable is a Boolean. I could use this variable to track whether someone has clicked a particular button on a page. Start it out set to false, and then sometime later when I know that the button has been clicked, set it to true. I can act on that information somehow. Booleans are important because they're one main way of getting answers from your programs about the state of your program's world. What I mean is, you can ask questions in the form of, is this true or is it false? It's one of the questions that JavaScript can answer for you without having to do a bunch of extra work. These questions that you can ask JavaScript and get back the answers for are generally in the form of comparisons. We'll look at these in more detail a little later on, but just to give you a preview, it looks like this. I'll make two variables. We'll say my location equals Santa Barbara, and my other location will be Los Angeles. And now I can ask a question of JavaScript. Are these the same? The way I can ask that question is by writing a statement and using 3 equal signs to tell me, are these exactly the same? So my location with 3 equal signs in between my other location. So I'm saying, is this exactly the same as this? And you can see that the answer is false. JavaScript knows the values of these two variables, and it can tell me whether or not they're the same. I define them right next to each other myself, so this is not all that exciting, but if there's a lot of other code in between the definition and the comparison where the values might change at some point, this can be a very useful question to get the answer to. So now if I change my other location to Santa Barbara, like this, and I ask the same question again, I'll hit the up arrow, I get back true. We're going to look at comparisons later, but one thing to note for now, variables are assigned with 1 equal sign, and comparisons use more than one. This is a very popular typo that introduces fun little bugs in the programs of developers of all levels of experience. So that's a look at Booleans, true and false, very useful for answering questions in your programs. So far, we've looked at some of the simplest types of data that JavaScript knows about. In this video, we're going to look at objects, which are a little more complex, but completely foundational and super useful. A lot of what we're doing in the code we write could be viewed as teaching the machine to do things for us. JavaScript comes with a lot of simple data types built in. We've seen numbers, we've seen strings, and we've seen Booleans. If we want to represent things that are more complex, that's where objects come in. Remember that we're assuming the scripts we're writing know nothing unless we give them something to know. Figuring out what knowledge our programs need, in other words, how to structure the data that we're feeding into our programs and getting back out of them, is a key decision. Objects are the main way in JavaScript and various other languages to encapsulate that knowledge in ways that are more complex than simple data types will allow on their own. The simplest way to make an object is with an object literal, similar to the string literals we saw before. Just type a curly brace and then another curly brace that closes it. That is an object. Now we can inspect this and we can see that there's nothing inside except for this little proto thing. We're going to ignore that for now. It's effectively an empty object. We can also, of course, assign variables. So I can say my empty object equals another of these empty object literals. I can look at my empty object as well. It's the same thing. I just have this magical proto object, which we will leave alone for now. For all intents and purposes, this is an object with nothing in it. To be really useful, of course, an object needs to have some stuff. You can think of an object sort of like a box of labeled folders. Every useful object has a series of labels known as keys and values, which are generally the data that we care about, that are all grouped together. So here's what that looks like with actual data. I'm going to assign this to another variable, which we'll call not_empty_object. And when I say that it's like a filing system, there are labels inside the object. So I'm going to hit Shift and return, and then type my first label. The label is a string, and when you're working in JavaScript, you'll see these strings with quote marks and without, followed by a colon. It's safest to use quote marks so you don't accidentally use a JavaScript reserved word for a key, but because it's fewer keystrokes, you'll see that a lot as well. Hit return accidentally there. So anyway, you put in the name of the key, then a colon, followed by the value. The value can be any type of data that JavaScript knows about. Numbers, strings, Booleans, other objects, anything. I'll put another string in here for this one. To add more folders to your box, you just add a comma. Here's a second label. Call it label 2. And I'll give it a value of value 2. So again, string followed by a colon, followed by the value. And you do this for as many items as you need in the object. The last value can also have a comma on the end if you want. That used to cause some issues in older versions of JavaScript, but not anymore. And then you close it with that close curly brace. Hit return to execute it. And now I can type the variable name and see my not empty object with its first label, second label, and the 2 values. Objects are very simple to create, but you can make some very sophisticated data structures using nothing but objects. And we'll be looking at that next. In this video, we'll look at some objects that are a little more substantial to get a sense of how we can use them to do data modeling. I'm here in my code editor looking at a few objects. These show some ways to model data with objects. These are still pretty simple, and we're still talking at a somewhat abstract level because the requirements of any given program are going to be up to you in your own work, but these will at least start to give you an idea. I've used these objects to represent 2 animals, a bird and a bear. We'll look at the bird first. What pieces of data I choose to include in an object are totally up to me, and because I don't have an actual program to write at this point, I just picked a few for fun. I have a genus, a species, common name, call type, which I've made squawky for this raven, something that the animal might say, nevermore, how many offspring it might have, and a couple of flags for whether it's noisy or deadly. These are Booleans, of course, but developers also call them flags from time to time. So let's copy this and try it in the browser console. And paste it in over here. And now my browser knows about this bird. Incidentally, you might want to watch out for things like a comma being missing. If I try that, I'm going to get a syntax error. So I'm going to redo this, making sure all the commas are there. And there we go. No errors. Now over here with my second animal, the bear, I've made all the key names the same, but they store different data. This is something that you can expect to do often, where you create objects that have a similar structure, but have different data contained inside. With this idea, you're starting to edge a little bit into the territory of object-oriented programming, which we'll talk about a little bit later. These animal objects map onto things in the real world, but you can also make objects of anything you need, concrete or abstract. Here, I've made a sort of book of knowledge. I can refer to it to find out things like when's lunchtime, and what's the ultimate answer, what the best song is, or what Earth is. So what you actually do with objects is going to vary a lot, depending on the kind of program that you're writing. But objects are a very powerful way, despite their simplicity, of representing data and making sure the computer understands the things that you need it to. In this video, we're going to continue looking at objects and see some of the things that we can actually do with and to them. I have my bird object here with a bunch of properties. If I want to inspect the object and find out what one of its properties is, here's how I can do that. I can type the variable name and then a dot. So if I want to see what the quote is, I can start to type quote, and I can see that it's nevermore. I'll execute that. And indeed, I get back nevermore. Now remember, I said that each of these keys is a string. And when you're creating these objects, to be safe, we can surround each key with quote marks, single or double quotes work. But when I'm retrieving a value from an object using dot notation, this will not work. I get a syntax error when I try that. But there's another syntax that I can use where I actually do use the full string. So if I try this again by typing an up arrow, instead of using the dot, I can use square braces. And that does work. If the keys that I've used include special characters like spaces or other things, I have to use this notation. It's exactly the same, just with a different syntax. So that's how you get stuff out of an object. Now let's say you wanted to modify this bird object and add some other information to it. The same syntax that you use to get things out of an object, you can use to get things back in using assignment, the same way that we assign variables. So I'm going to clear this console. Let's say I want to give this bird a color. I can use dot notation the same way without the quote marks, and I can assign that new property that doesn't yet exist to black. And now if I inspect the bird object, hit return here, I can disclose this whole thing. And now I have a new property called color with a value of black. And if I want to use the same string syntax with the square braces, that also works. So let's say I wanted to add a property called where it lives with spaces and so forth. I can also do that and say it lives in a tree. I'll inspect bird again. And there we go. Where it lives is in a tree. One way you can get around having to use this square braces notation would be to phrase your keys like this. So let's say I have a bird and I want to say where it lives. I can do it like this. There's no spaces or other characters that can cause the dot notation to break. This is called camel case notation. First letter is lowercase, and each subsequent letter that starts every jammed together word is uppercase. The particulars of camel case are not required. It's just a common way of writing variables and properties in JavaScript. So I could also set this to in a tree. I can use either notation to get that same property out of the object. That's how you add things to an object. If I want to remove a property from an object, I can do that as well. This is done using the delete keyword. So I type delete, and then the property that I want to delete from the object. So this would be bird.color if I want to remove color from that bird. Now let's look at bird again. Color is gone. And delete works with either notation. Finally, I'll just note that whether an object starts as an empty object or whether it already has some properties in it, all this adding and deleting business works exactly the same with exactly the same syntax. So that is an overview of some of the basic manipulations that you can perform on objects, retrieving things from them, adding things to them, and deleting things from them. When working with JavaScript objects, there's an important concept called references. Objects are references to particular locations in the computer's memory, and that impacts your ability to work with them in different contexts. So here in my editor, I'm going to copy this animal object, bring it over into the browser. I'll paste this. Just check its value here. Okay, looks fine. Now I'm going to create another variable called animal2, and I'm going to assign animal to that. And if I check its value, here's what I get. It's all the same stuff. Now the question here is, what have I actually done when I executed this statement up here? Did I make a copy of the animal object? Let's find out. So you might think that if I say animal2.genus equals, let's change this to Ursus, which is a bear. Okay, now I'll inspect animal2. I can see the genus is set to Ursus. Okay, that's what we expect. But let's check the original animal. I don't see anything changing down here. Yeah, I have changed both animal2 and animal. So what we've exposed here is references. This statement does not actually make a copy of the same object. This is saying, assign this animal2 location in memory to the same location in memory as the original variable, animal. So these two variables reference the same memory and really are the same thing. You should only expect to run into this when you're working with objects, but it's an important point. The statement does not make a copy of the object. It just gives you two variables that point to the same value, the exact same value. So if I want animal2 to be a copy of all the same stuff, I have to execute the same assignment line that put in all that data. I'm hitting up arrow a bunch of times to get back to this original statement. Now if I change this to animal2, we can see that animal is Ursus and animal2 has the genus of Corvus. So these really are two different things now. If I want to be really clever, I have another snippet here in my JavaScript file. I can use this. It uses a built-in JavaScript object called JSON to convert the object to a string of JSON and then reparse it into an object. I don't expect you to know how to use this right now, but if you want to make a complete copy of an object safely, this will do it. This is pretty much the way most JavaScript developers do it now. Anyway, once I've done this copying, I can change animal2 however I want to. Set its genus to human. And now animal stays the way it was, and animal 2 stays the way it is as well. The two are now really actually different objects. Always keep in mind that when you execute a statement like this, where this one is an object, you're not making a copy of it. You're reusing a reference to the same value, the same location in the computer's memory. In this video, we're going to talk about arrays, which are a way of storing lists of data that preserves their order. We've already looked at objects, which let you group data together. But there are some cases where you want to store, say, a list of things, and the order that those things appear in is important. For example, let's say you wanted to store the days of the week, which of course appear in a certain order, or the months of the year, something like that. In cases like that, you want to use an array. So, how do we make one? Let's make a variable. Call it myArray. Instead of using curly braces like we do with objects, we just use square braces like this. So now if I get my array, I get back an empty set of square braces. If I want to create my list of days of the week, I'll make another variable, call this days of the week. 2 square braces, and now I'm going to fill it in with some days of the week. Sunday, Monday, Tuesday. I'm not going to bore you by going all the way through these, I'll just make a few. And then if I type out the name of the variable, I can see the whole thing here. And Chrome even shows me how many things are in the array. As you can see, unlike an object where the order of the keys isn't guaranteed, an array preserves the order that I put things in. And there are no keys, only values. Actually, that's not entirely true. There are keys, they're just not displayed here. Secretly, an array in JavaScript is actually an object that gets special treatment. This is not the case in every programming language. In many programming languages, there are objects, and there are arrays, and they are totally different. In JavaScript, they're effectively the same, but arrays have a few special qualities. One is that the order is preserved, but another is that the keys are automatically assigned, and they're assigned as numbers starting with 0. So even if I don't care about order, I can fill in an array with a list of stuff and not have to think about naming the key for each stored value. Again, you can create arrays with any kind of data. So I'm going to reassign my array, and I'm going to fill in some numbers. Let's put in some strings. Maybe a couple of Booleans. There we go. Okay, let's check the whole array, and here it is. All different types of data, and they're all in the same order that I put them in. Arrays are often used for lists. So if, for example, you wanted to store the counties for some area because you're making a program that needs some kind of geographic knowledge, arrays are a good fit. I'm going to save you watching me type these out. I'm just going to grab this from my editor. I'll paste it in. So here are a few counties, and now my program would be aware of this list of counties. You could put them in any order you want. In the case of something like this, the order might not, for the purposes of your program, make any particular difference, but if it did, you'd have already guaranteed that they appear in this order. Let's make one more new one, call it array of stuff. And here's the thing, arrays can contain objects. So I can put an object in here. So the first item in my array is an object. You can even, if you want to, have another array inside your array, along with any other values that you might want to put in there. JavaScript doesn't care what type of data anything inside your array is. So here we are. Here's my array of stuff. First, I have my object, then my nested array, then my Boolean, and my string. You can nest arrays inside other arrays as deeply as you need to. You can make an inception array. There's one more thing I want to point out about arrays that's different from regular objects, which is that they know how many things are in them. Just as strings know how long they are, any array also knows how long it is. So if I want to see how many things are in my array of stuff, I can access the length property like this. All arrays have a length property. I can see that this one is 4 long. This doesn't account for all the nested data. It's only how many objects are at the root level of the array. There will be some occasions in your programming where you're going to want to use arrays, and there will be some times when you're going to want to use objects, and you'll want to combine them in various interesting ways. It all depends on the requirements of whatever you're writing at the time. Right now, we're just going through syntax, so you can know some of the tools that are available to you in the JavaScript toolbox. And that was a look at arrays, which can store lists of anything you want, preserving the order that you put them in. In this video, we're going to get into manipulating arrays, how you can see what's in an array, and how we can take action on the contents of an array. We'll use this counties array with a few counties in it for demonstration purposes. I copy this and bring it over to the browser, paste it in. If I want to get a specific item from an array, I need to retrieve it using the square braces notation we saw with objects. Although arrays are technically objects, the dot notation doesn't work, only the square braces. So to get the first item from counties, I use 0. Always remember, arrays are what we call zero-indexed. Each item in an array is assigned an index, same as the key in an object, but with arrays, we just usually call it an index. And those indices start with 0, always. Just to be 100% clear on this, the first item is 0, and any other item would be retrieved by its index from there, 1, 2, 3. So let's try 2 here. 0, 1, 2, and we get Carol. The way this syntax is often read out loud, where 2 here is the index, would be counties sub 2. We can also use this notation to modify the values in an array. So I can say that I want index 2 in the counties array to be Cheshire. And then if I look at counties, 0, 1, 2, there it is. I've replaced Carol with Cheshire. Geography buffs may know that these are counties in the state of New Hampshire. So that's how you manipulate things that are already in there. Now I want to add to this array, and there's different ways I can do that, including using the same notation. If I want to add something onto the end of the array, I can do it by hand, counting to what the last index should be. I know that this is 0, 1, 2, 3, and so the next available index would be 4. So I can add a new county there. We'll add Carol back on. But in the context of programming, doing things this way is not always going to work. There's going to be a lot of unknowns, a lot of uncertainty at any point during the execution of your program. You're going to want to do things in a more abstract way. So if I want to stick something on the end of an array, I can type counties like this with the square braces, and now inside the square braces, I can use an expression that will evaluate to a number. So I can say counties.length in here. And this would evaluate down to the next number, which in this case, because I've already gone up to 4, would be 5. I'll add Merrimack. So I've added on to the end of the array this way. There's another way that I can add something onto the end of an array using the push method that every array knows about. So I can write counties.push with some parentheses. And then in those parentheses, I can add the name of the thing I want to push. This time I'll add coas. Yes, that's coas, not coos. So that's a few ways of pushing things onto the end of an array, and therefore adding to it. Now, if I want to remove something from the array, I can use a similar method to push, only in this case, it's called pop. Counties.pop with parentheses, and I put nothing inside those parentheses, and I get back coas. And if I look at the array again, I can see that it's modified. Coas is no longer in there at all. It's not just that it gave me the last item, it actually took it out. These methods, push and pop, are used often in combination with arrays to grab something from wherever it is. We're talking in abstract terms, I realize, but sometimes in your program, you'll need to store some items and then retrieve them later. You can push an item onto an array and then pull it back off later when you need it. So for example, maybe you're writing a piece of code that's going to look through the entire content of a web page and look for images of a certain size. Every time you find one, you want to store a reference to it. So you could push a reference onto an array every time you find one, and then later, when you finally collected them all and you want to do something with them, you can pop them back off. Push and pop work on the end of an array, and there are equivalent methods called shift and unshift that work on the front of an array. I'm going to show you just one more of the ways that you can manipulate arrays. What if you wanted to remove something from the middle? We've seen this with objects where we used delete to get rid of a particular item. But this doesn't work with arrays the same way it does with regular objects. If I try to delete index 2 from counties, that's the third item in the array, and then I look at counties, It's still the same length. It's just that the item that used to be here has been replaced with an empty value. So the array hasn't changed in size, it's just that this one index has changed in its value. If we want to actually delete something from the middle of an array, we need to use another method called splice, which looks like this. We could say counties.splice, and then it takes two parameters inside the parentheses. The first one is which index of the array we want to do the operation to. So we want to get rid of that undefined item. So we'll put in 2 here, and then a comma. And the second parameter is how many items we want to get rid of. So in this case, that's going to be 1. And this returns the item that we removed, which in this case is just empty. Now, if I look at the counties array again, here we go. We've actually cut the array down so its length is what we expect it to be with an item removed. This is important to remember with arrays. The length always refers to the number of slots in the array. It does not matter whether the slots have anything meaningful in them. For more on arrays, check out the Mozilla JavaScript documentation for a full list of what's available. But now you've had a taste of how to manipulate arrays, how to read what's in them, add to, and remove from them. In this video, we're going to talk about how to make your code more readable through the use of Whitespace. I have here a little block that assigns a few variables individually. It's pretty much no Whitespace at all, but it does work. If I copy this, switch over to the browser and paste it in, all of my variables have been assigned here. So it works, but it's not that easy to read. What I want to do here is add some whitespace, which is generally ignored by JavaScript, makes reading code much easier. So this can take the form of putting some spaces in between. Or I can put assignments on multiple lines like this. Sometimes you'll see code where people have really curated their whitespace, making sure all the equal signs line up in a series of assignments. This looks pretty nice, but it's a little tedious to do by hand. So if you like this style, look for a plugin for your code editor that can help you do this. Likewise, when you're creating an object, here we have no whitespace, and you can read it for the most part. It's a pretty simple object. But if I add some whitespace to it and some carriage returns, it becomes a lot easier to read. We saw previously that you can break strings up across multiple lines using backslashes, which is another use of whitespace. When you do this, make sure that each of your lines really ends with a backslash, that there's no spaces sneaking in after those. If I add one in here, you can see all these squiggly lines showing up in my editor, which tells me that this is not valid JavaScript anymore. Something's broken. If I remove the space, everything goes back to normal. If your editor doesn't provide a feature like this, where all these squiggly lines show up, finding a bug like this can get very tricky. So just watch out when you're using backslash notation like this. Now, the way that you set up your whitespace is something that programmers will, for lack of a better word, fight over. There are elements of personal preference, or if you're working on a team, there may be a coding standard everyone is expected to follow to make sure that everybody can read each other's code well and that the results are nice and uniform. There are even tools like Prettier that can take your code, however you've written it, and automatically add whitespace and do other formatting to it to make it readable. I've become a pretty big fan of Prettier and use it in all my JavaScript projects. In any case, when you're starting out, you might just be working on your own projects for yourself, and the main issue is to keep your code readable for yourself. However carefully you want to do it, I recommend embracing the use of whitespace to make sure your code is readable without affecting how it's executed. In this video, we're going to talk about comments, which are used for documenting and disabling parts of your code. The most important function for comments probably is documentation. That is, adding pieces of code that don't execute but can be read by other human beings to understand what's going on in your program. These come in 2 styles in JavaScript. One is the line comment, which starts with 2 slash characters like this, and then anything after that on the same line doesn't execute. These can be at the beginning of a line like this, or anywhere else. So if I wanted to document one of these variable assignments for some reason, I can put a line comment right here toward the end of the line, and that works just fine. This is not really documentation of the year. It's clear enough from the variable name what it's doing, but this does work, is the point. The other function of a JavaScript comment is to disable parts. So if I want, say, this line, the day, not to execute anymore, I can comment it out. Let's copy this and bring it over to the browser. Now if I paste this in, this line did not execute because the whole thing is actually a comment. So now year is defined, month is defined, and holiday is defined, but day is not. I get a reference error. So when you're working through your code and fixing things, being able to comment things out so they don't execute anymore can help you isolate what might be wrong. It's a really handy debugging tool. There's one more style of comment you can use in JavaScript called a block comment. It starts with a slash, followed by an asterisk. And then you can write comments across multiple lines, like this. And finally, it ends with an asterisk and another slash, like that. You'll see these all the time in JavaScript for inserting long paragraphs or just other elements where a lot of text is needed in one place, and maybe it would get a little bit tedious to put double slashes in front of every single line. Now you can see that these will break across lines, so you can do this to disable many lines of your code at once. My editor makes it really obvious what's contained in the comment. Thank you, syntax highlighting. Right now, this is commented from here all the way down to the next asterisk slash right here. Block comments are really useful, and you'll see them all the time. But you need to be careful with these because every once in a while, an asterisk and a slash will appear as actual valid code that's not part of a comment. And this is not a problem with line comments. So if you're commenting out something like this down here, and I try to comment this out using a block comment, you can see that it doesn't work because there's an asterisk and a slash in the middle of this totally valid line. For this reason, some people recommend against using block comments at all. I'm not going to go that far, but it's something to watch out for. Now let's look at a very large JavaScript file with a lot of documentation in it. This is jQuery, a very popular JavaScript library. This is a version of it that hasn't been optimized, so it's loaded with comments, starting with a big block comment at the top, and then lots and lots of line comments below. As you scroll down, you can see that nearly every useful block is documented with a comment. This is very nice for people wanting to contribute to the project and for developers wanting to learn how it works. Now, of course, jQuery is a very large JavaScript library. There's a lot going on here. No amount of comments is going to make it perfectly clear the first time you read through it. You still have to do a lot of reading and actually read the code and understand it. But having these comments in here is a huge, huge help. I really can't recommend highly enough making sure that even if you're the only person that you ever expect to read the code, add lots of comments because it will always help you. It's just a little bit of extra effort, and it can pay off huge if you set your code aside for a while. To be able to come back and have something to read other than the code itself that tells you what your intentions were is really useful. So that's a look at comments in JavaScript, what they can do, which is allowing you to document your code for your own readability and to disable portions of it, which can be helpful in debugging. In this video, we're going to take a look at regular expressions, which are a way of searching text for patterns. When you're working with text in JavaScript, working with strings, but also if you're working with long runs of text in prose or pretty much in any situation, there may be times when you want to find a particular something, but it may not be an exact something. Maybe you can describe a pattern that it should follow, 2 digits followed by any number of letters, or any word that starts with A and ends with S. A regular expression is a way of describing something you're searching for in an abstract way. In JavaScript, a regular expression is another data type just like numbers or strings. And it looks like this. This is a regular expression literal. Now, if we just have 2 slashes, of course, that's a line comment. To make it a regular expression, we put something in between those slashes. That can be words, it can be numbers, it can be various combinations, and it can even be patterns. We're just going to look at some simple examples in this lesson, but entire books have been written on regular expressions, including this one. If searching text on a regular basis is something that you do because you're a programmer or for whatever reason, it could definitely be worthwhile to check out a book on regular expressions. They're tremendously powerful. Anyway, here's how they work. What we're going to do here is take these 4 strings, which as you can see have different stuff in them. And then we have this regular expression in a variable called regex. And it's just a very simple one with the word this in between the 2 slashes. So what we're going to do is we're going to take this regular expression and we're going to execute the test method on it, passing in each of these strings separately, 1, 2, 3, and 4. Then we're going to take the result of that and print it to the JavaScript console from our code using the console.log function, which is built into the browser. It's basically equivalent to just typing out the same expression right in the JavaScript console. You can use this function anytime you're working in your code editor to get whatever that expression is that's in these parentheses into the JavaScript console. It's very basic, but it's a very useful debugging tool. We're going to work directly in the JavaScript console, so this is a little bit redundant, but I wanted you to be aware of this built-in function for later use. So what happens when we use this is the test method looks through whatever string is passed in for this pattern, which is expressed in the regular expression. And it reports back true or false whether that pattern can be found in the string. So let's copy and run all of this code and see what happens. Here are the results of my 4 tests. The first one came out false. We're searching for this. The word is in there, but not in this specific case. So that's accurate. Likewise, the second one came back false. Same thing. This appears, but it's all lowercase here and title case here. Then here, it does appear in lowercase, so that returned true. And the same thing for returning false on this 4th one. This can be useful in a lot of different ways. You can check for a word or phrase or whatever in a block of text of any length and get your results back pretty quickly. Now, there are a lot of modifiers you can add to these regular expressions to change how they work. Let's try a few. So I'm going to clear the console, but bring back my giant block of code by typing the up arrow. First thing I'm going to do is add an I onto the end of this regular expression. You can see that it's still colored in red, just like the rest of the expression, so I know that this is going to work. This I is called a flag when added onto the end of a regular expression like this. I stands for case insensitive. Now I'm going to run this again. Every test comes back true, because the word this appears as long as we don't care about what case it's in. I'm going to clear this again, bring the whole thing back by typing the up arrow. Here are some other basic modifiers we can add to this expression. I'm going to leave the case insensitive modifier, but I'm going to add what's called a caret to the front of this. That's Shift-6 on an American keyboard. Now what this does is check if this appears at the beginning of the string. So comparing in a case insensitive way, these 3 all have this at the very beginning. This one does not, so it goes true, true, false, true. There's a similar modifier that I can use to check for whether something appears at the end of a string. So I'll get rid of the caret, put a $sign here at the end, and this will check whether the word this appears at the end of any of these strings. Execute this again, and they all come back false because this does not appear at the end. Clear one more time. Bring this whole thing back again. So I'm going to try something different. I'm going to check for ever with the $sign. Hit return. Now I get true and true for the first 2, and false for the second 2, because ever does in fact appear there at the end. Now there's something a little tricky about this particular regular expression, because a dot has a special meaning here. A dot means any character. So I'm not actually matching whether ever and period appears in these strings. I'm checking whether ever followed by any single character appears here. If I want it to check for a literal dot, I can do that, but I need to escape this little dot. If I run this again, I get the same true, true, false, false. But now I'm really checking for the period instead of just any old character. And that is an introduction to regular expressions. This topic has applications way beyond JavaScript. I know when I first learned how to use them, it felt like the text world was my oyster, and I hope they're very helpful to you as well. In this video, we're going to look at simple comparisons, which are the beginning of the way we could start to ask the computer a question about something and get a meaningful answer back. First, we're going to look at equality. That is, knowing whether something is the same as something else. We can start out really easy. I'll create variables for 1 and 2 because most of the time, at least one of the items we're asking a question about will be a variable. So we'll start out by asking if 1 is the same as 1. We're using 3 equals signs to do this. This operator is called the strict equality operator, and it tests whether the object on the left is identical to the thing on the right. And we can see that this is true. There's a similar operator that asks whether this is not equal to that. So I'm going to type an up arrow to get back what I had before, and I'm going to change that first equal sign to an exclamation mark or a bang. This is called strict inequality. So in this case, we're just asking if 1 is not identical to 1. And as we would expect, the answer is false. Now if I change the 1 to a 2, I'm asking if 1 is not identical to 2, and that is true. And then finally, if I change the not identical back to identical, is 1 identical to 2? The answer is false, no. These kinds of comparisons are all over the place in most programs. You might be asking, is this page's URL about.html, or is the button that was just clicked the main menu button? Checking whether something is equal to something else is a comparison you'll be doing a lot of. There's another pair of operators that are similar, but act differently. You'll see them a lot in programs out in the wild. These are simply the equality and not equality operators, with only two equal signs. So for example, 1 double equals 1. This also checks equality, but in a way that's not as strict, hence the difference in the names. This first comparison still comes back true because they are exactly the same. You start to see a little bit of weirdness when testing a number with a string. So let's say I want to check against the string 1 instead of the number 1. This is true-ish, I suppose. I mean, there is a 1 in there, but it's a string, not a number. Strictly, they're different, but this operator sort of converts the data types and says, sure, they're the same. There is also a not equal operator where I change that first equal sign into an exclamation mark again. And that's how we do inequality. It's generally recommended that you use the strict versions of these operators for the most predictable results in your code, but people still use the non-strict versions a lot as well. The particulars of which kind of values will return true or false for the equality or inequality operator are a little too detailed to go into, especially for people who are just starting out. You can look at the comparison operators page on the Mozilla Developer Network for more on this. But do note that if I change this to strict equality, I'm starting to get results that are maybe more what you expect. So 1 is not the same as the string. It is different. JavaScript also has relational operators, which are straight out of your math class. So we can ask, for example, is 1 less than 2? And yes, it is. Then we can say, is 1 greater than 2? And of course, it is not. We can also ask a combination. So I can say, is 1 less than or equal to 2? This is an angle bracket followed by an equal sign with no space in between. So here we are asking, is 1 less than or equal to 2? And yes, it is. If I change this to a 1, is 1 less than or equal to 1? Yes. And then I can flip this angle bracket and ask, is 1 greater than or equal to 1? Still yes. What about, is 1 greater than or equal to 2? And now we get an answer of false. Of course, change this to a 10 and I get back true. So that was a look at simple comparisons, the various equality operators and the relational operators. Expect to use all of these very often. In this video, we're going to look at some simple operators that are used for doing math. You're not going to need to do a lot of math in the examples we're going through in this course, but simple arithmetic comes up pretty often. The first 4 operators are pretty simple, and if you've ever used a calculator program on a computer, they'll probably look familiar. We, of course, have the plus operator. So 2 plus 5, that equals 7. We also have minus, which is technically a hyphen. So 4 minus 3 equals 1. Of course, we're not restricted to the counting numbers. We can do negatives as well. So like, let's say 5 minus 9 equals negative 4. To do multiplication, we don't use an x. We use an asterisk. So 3 times 5 is 15. And then finally, we use a slash to do division. So say 36 divided by 6 equals 6. And when you start getting into fractions, the result is expressed using a decimal point. So these are all fairly straightforward, probably nothing you haven't seen before. But now we're going to look at a few things that might be a little unusual. The first one is the modulus operator, which is the percent sign. Looks like this. The modulus operator takes the first operand, which in this case is 20, divides it by the second, and returns the remainder of that division. This is often used in programming to determine whether a number is even or odd. But it could also tell you something like, if I'm showing a list of search results in groups of 20, and there are 254 of them, how many will be on the last page of results? Anyway, this is what the usage looks like. So this is 20 divided by 2, which has a remainder of 0. But if I change this to 19, the remainder is 1. If we wanted to find out if a number was even, we'd do a comparison that looks like this one. Normally, we'd use a variable instead of a scalar value, like 20. That's what we call it when we're using a value directly instead of assigning it to a variable first. But doing it this way makes what we're checking very clear. So that's the modulus operator. Now let's look at incrementing and decrementing, which is something you do all the time in programming. Let's say I have a variable called counter. I'll set it to 0 to start. Many times when we're working through something in programming, you need to keep track of how often you've done it. Every time you do whatever that unit of work is, you tell a counter, all right, I've done this one more time, go increment yourself. There are various ways that we can do that. The first is to take counter and assign it to itself +1. That works, but it's a little verbose, and there's always this tension in programming between keeping things verbose so they're easy to read and making it so you don't have to type a lot of stuff over and over again for something that you do often. So there are various ways to express the same thing that are a little shorter. The first one is to take your variable name and use the +=, also known as the addition assignment operator. So in this case, if I say counter +=1, this is expressing exactly what the previous statement expresses, but it's a little shorter. Still pretty clear though. So now counter is 2. Another common way is to take the variable name and simply add 2 plus signs on the end of it, like this. Now this returns 2, but the actual value of counter now is 3. This will only work for incrementing by 1, whereas with the +=, you can increment by whatever you want. So I could say counter +=5 if I wanted to. And it even works with negative numbers. So I could say counter += -4. You can use whichever of these feels right to you. Similarly to incrementing, there's also decrementing operators, which are exactly the same thing, except instead of using a plus, you use a minus. So if I want to count down from somewhere, I could say counter -=1. And then counter -. So again, it returns the previous value, but the actual value now is 2. One thing that's worth mentioning is that all the arithmetic operators we've seen so far can work with this assignment syntax. So for example, if I say counter *=2, that will double it. It was 2 before, and now it's 4. I don't see this kind of construct very often outside of incrementing and decrementing, but if you see it, that's what it means. And this works for pretty much all arithmetic operators. One more note about these. Plus also works on strings, but when you use it with strings, it's called a concatenation operator. So if I say cat plus dog, it gives me cat dog. They're stuck together. If you want to combine strings as words, you need to make sure that spaces are included somewhere in there. So in this case, cat space plus dog will give you cat and dog as separate words, but in a single string. And this doesn't work with just 2 strings. You can add more strings onto the end here. So we could say cat and dog, like this. So the plus operator works on strings to concatenate them together, while working in arithmetic terms just as simple addition. And that's an overview of the most common and probably most useful arithmetic operators and what they do, including a little exception on how they work with strings. In this video, we're going to talk about the main logical operators in JavaScript: the logical AND, the logical OR, and the logical NOT. When you're working through JavaScript, there will be times when you want to do comparisons on more than one thing at a time, basically asking a question in multiple parts. And the way you can do that is by grouping things together with either an AND or an OR. The AND in JavaScript looks like this: 2 ampersands. And the OR is 2 pipe characters, which on an American keyboard you can find right above the return key on the \/ key. You hold down Shift, type a \/ and you get a pipe. So how do we use these? I'm going to copy a few variable assignments and bring them over into my browser, paste them in. Animal 1 is a monkey, animal 2 is a bear, and animal 3 is a tiger. Let's say there's a bunch of code that does some other stuff somewhere in the middle, and later on I want to come back and check the state of these variables. I can use the strict equality operator to ask JavaScript, is animal 1 still a monkey? And maybe I want to ask at the same time, is animal 2 still a bear? If it's important to ask these 2 things together and then execute a piece of code, only when that whole thing is true, then I can use the logical and add on my second condition, like this. I'm asking, is animal 1 a monkey? And is animal 2 a bear? And that whole statement evaluates down to true. JavaScript is saying, yes, this is all true. Now, if I wanted to find out if animal 1 is an ape, and animal 2 is a bear, JavaScript returns false. The idea here is that the AND operator will return true only if every condition you pass to it separated by that AND is true. This is the case no matter how many comparisons I add on. If any one of them is false, the entire thing still evaluates to false. For a bunch of these ANDs to come back true, every single one of them must be true. If I only care about one of these conditions being true, I can use OR instead. I can ask, is animal 1 a monkey? Or, using 2 pipes, is animal 2 a bear? And that's true. If I change monkey into an ape, now I'm asking, is animal 1 an ape, or is animal 2 a bear? Animal 2 is a bear, so this part's true, which makes the whole thing true. For ORs to return false, the entire thing needs to be false. You can also combine these ANDs and ORs on a single line, but now things get a little more complicated. JavaScript has a notion of operator precedence, which determines which of these things will be evaluated first and then collapsed into its true or false value before being compared against the others. And in JavaScript, with operator precedence, the ANDs are always evaluated down before the ORs. So what that means is these two, because they have an AND between them, would be collapsed down into their value of true or false, whatever it is. And then this comparison would be checked. So if I have a series of comparisons and I need to make sure that some ORs are kept together instead of being eaten up by these ANDs, I need to add some parentheses, something like this. So this would make sure that these ORs stick together for the purpose of evaluating down to true or false, whichever it is. Now I know at a certain point your eyes could be rolling into the back of your head from seeing true and false all the time here, but there will be times in writing your own code or in reading other folks' code when you're going to see lots of comparisons, and hopefully they will have made things a little easier for you by putting in lots of parentheses and generally trying to make things as clear as possible. One more thing about logical operators, you can also use the logical not, an exclamation mark or bang, to invert things. Here's how that works. So we would say not true, which is false. Likewise, not false is true. You can apply not to entire comparisons as well, wrapping the whole expression in parentheses and sticking a not in front of it. That takes the entire expression, whether it evaluates to true or false, and then inverts it to the other one. And just to be clear, the not isn't just altering the strict equality operators. So this is not the same as this. It also flips any ANDs to ORs. So it's sort of like a magic wand that touches each of these pieces and changes it to the other one. Being able to ask these questions with logical operators is something that you're mostly going to see when we start getting into control structures, which are how you execute certain portions of your code and maybe not others. You won't as often be writing out these statements like this, bear, without some sort of control structure, like an if statement or something along those lines. But now you've had an introduction to the main logical operators, and, or, and not, and some of the various things that they can do in your code. A control structure in programming is a way to modify the flow of execution. Like it's deciding whether to execute at all, or how many times to execute something. In this video, we're going to look at one of the fundamental control structures, the if statement. An if statement is what you use to branch in your code, depending on certain conditions. What we're going to do first is assign a variable based on a prompt for user input. So here's a piece of code right here at the top of this file. I'm going to assign a variable called answer to the result of this method called confirm, which is part of the window object that JavaScript has available in all web browsers. I'm going to copy this and switch over to the browser and watch what happens when I execute this. You can see that the string I passed into the confirm function is rendered right here. And based on which of these two buttons I click, I'm going to get a different value in the answer variable. So I'll click OK first. Let's see what answer contains. True. I'll run this again, And I'll click cancel this time. And I will check the value of answer now, and it's false. So in the course of a program, you might want to ask the user for an answer to something, and this window.confirm function is a way that you could do that. Having retrieved an answer, now I need to take some action based on what the user said. One way I can do that is with an if statement. Here's what that looks like. I type the word if, followed by parentheses, and in those parentheses, I put my condition or conditions. If whatever's in these parentheses evaluates down to true, I'll do whatever is in these curly braces that follow it. So here, if answer is true, I'm going to log a message to the console using the console.log function, and it will say, you said true. Let's copy this whole thing and try it. Click OK. And there it is. You said true. Let's execute the same block again. I'll hit up arrow and then return, and click cancel this time. Nothing happened. No message. So you can see that by asking this question in the form of an if statement, I got to execute this code or do nothing. This is actually really useful, and you'll see it all the time. So let's extend this to take a different action based on whether the answer was true or whether it was false. Here's a block that does that. So here's a longer block. We're going to copy this whole thing and bring it over into the browser. I'll clear this, paste this in. I'll get rid of what we don't need. So this looks just like the previous if statement, except now I also have an else block that follows it. The if statement has curly braces around it, then else, another set of curly braces, and another line. So if this evaluates to true, the first block will execute. And if it's false, the else block will execute. So let's try this. I'll hit return to execute it, click OK. It says you said true. I'll hit the up arrow again to bring the whole thing back, return to execute, click cancel. And now it says you said something else. So when it was true, you said true. When it was false, you said something else. So this is how you can branch in your code and do certain things under certain conditions and other stuff in other conditions. If statements can be extended even further. Let's take another longer block of code. Right here. I'm going to copy this and bring it over into the browser. This time we're using window.prompt instead of window.confirm. This is going to prompt me for an answer using a text field. So I'm instructing the user to type yes, no, or maybe, then click OK. And then I'll take some various actions based on what the user said. Let's try it first to see what it does. Here we go, type yes, no, or maybe. I'll type yes, and it says, you said yes. Let's just do this a few times. Now I'll say no. You said no. Try it one more time, and I'll say, hey. And now it says, you rebel you. Okay. Now that we've done this, let's look at the code a little more carefully and break it down. So what's happening here is I'm checking each of these in turn, and instead of just using else, I'm using else if blocks. So first, I'm checking this one. If answer is yes, I'll just do what's here and skip everything else. If it's false, then I'll jump down to the next one and check if answer is maybe instead. If it is, I'll do what's here. If not, I skip down to the next one, and so on until I get to the else. If I strip any of these out, it won't be taken into account anymore. Say I decide that I don't need to specify maybe anymore. I can just remove this condition. So now I'm only checking for yes or no. Anything else is going to be considered rebel talk. So if I type maybe here, it says you rebel you instead of responding specifically to maybe. You can have as many lines as you want inside these if blocks. And the conditions in these parentheses don't have to be a single simple comparison. You can add in logical operators. So switching back to my code editor one more time, here's a block that's got a lot more going on. So first, it will check this entire expression, which in this case would be acting on yes or no, and doing some common actions potentially if either of these answers is true. Then I have some nested if blocks, which checks specifically for whether the answer is yes here, and does some specific actions for when we say yes, and I can simply use else to cover anything else, which, because of this condition, would only be no. And of course, if it was not yes or no, I would move on and cascade down these other blocks. So you can see there's a lot of power in being able to branch off and do different things in your code based on different conditions, whether it's input from the user or conditions that you created in your own code yourself. But this is how you can use if statements to execute different code under different conditions. In this video, we're going to look at another way of doing conditional branching in JavaScript, which is the switch statement. These are similar to if statements in results, but they look different and act differently at times. Here's our example using if statements. And we have a bunch of ifs and elses in here. Works great, but if you have a lot of else ifs, it can start to get a little tedious writing that over and over again, adding all the braces and so forth. At times like this, you might consider using a switch block instead. Here's what this same thing looks like written using switch. We start by saying switch, and then in the parentheses, we put an expression that we want to evaluate. Most of the time, it's going to be a variable, but it can be anything that evaluates down to an expression that you can check below. But as I say, usually it's a variable. Each of these subsequent blocks is called a case block. It's the keyword case, followed by a value, and then a colon. The colon can have spaces before it or not, doesn't matter. And then after that case is what's supposed to happen, just like with an if block, except there are no surrounding curly braces. Instead, each block ends with the keyword break. So in this case, I'm asking, what is the value of answer? I start here, and if the answer is yes, I'll execute what happens here and then break out of the switch block. If it's not yes, I'll check here next. Is it maybe? If it is, then I'll execute whatever's in here and break out of the switch block. Same thing. If it's no, execute here, break out, and so on. Now, as with an if block where we can have an else condition at the end, with a switch statement, we have a default at the end. Default in a switch is just like else in an if block. If none of the other stuff matches, we execute this block and finally also break out of the switch. So let's copy everything. I'll switch over to my browser. I'm going to remove the if block, and we'll execute this whole thing. Let's try yes. You said yes. And up arrow to try it again. Try maybe. You said maybe. I don't know what to make of that. And one more time. Cookie. You rebel you. Okay. So far, this works exactly like an if block. It's just written a little differently. But there's one thing that's a little tricky with switch statements, and actually useful, that you need to be aware of. They can cascade in a way that if statements don't. So I'll use the up arrow to get this whole block back. And I'm just going to do one thing. I'm going to remove break from the yes block. Now I'll execute it. Watch what happens when I type in yes. Not only do I get you said yes, I also get you said maybe. Just to be clear of what's happening here, I'm going to try this again and type maybe. And I only get the maybe block this time. So this is the thing about switch statements. If you don't include a break, the execution will continue down subsequent case blocks until a break is hit. I typed in yes. So first I hit the yes block, and it executed you said yes, and then it continued down into the maybe block and did whatever's next. And it kept going until it got to a break. So you want to be careful with this. If you just want a single block to execute for each case, then you need to include that break statement. You can also leave it off on purpose, of course, if you want a block to be able to cascade down several conditions in certain cases. If statements kind of can't do that easily. Most of the way that ifs and switches work is the same in popular usage, and which you want will be a matter of taste. The curly braces of if blocks can be easier to read for some people and can be better supported by some code editors than switch blocks. But for lots of branching, a switch can be more pleasant to read and write. It's really up to you. In this video, we're going to look at a few of the forms in which if statements will be made shorter. You may write these in your own code, and you will certainly see them if you start looking at other people's JavaScript code. First, the one-liner. So I'm setting a variable up here for a cherub, who is going to start out as Cupid. I have a comment for making the cherub some other guy. So first, we're going to copy these first few lines and bring them over to the browser. And you'll notice that I've put this if statement entirely on one line with no curly braces, and it will still work. There. So I executed it, and the cherub is Cupid. So having checked that, I still log this message to the console, even though there's no curly braces. Likewise, I can include an else block on the next line, again with no curly braces, and it'll still work. Let's paste this in. We know that cherub is still Cupid. So I'm still getting the same message. But if I change the cherub to some other guy, and then I execute this line again, I'm getting my else block. One-liners are fine for quick checks, but if you want multiple lines of actions to be executed after a condition is evaluated by an if statement, you should add curly braces back. Only the first line that comes afterwards is bound by the if statement when there are no braces. For that reason, and just generally to avoid confusion, I rarely use these one-line versions, and pretty much always add curly braces in case I need to add more to an if block later. Another thing you'll see is a condition that's just a variable by itself. Here's a block using that. I'm going to copy everything here, bring it over, paste this in. Let's talk about it first. We have some variables here for what we want for Christmas, what we got for Christmas, and whether we will get upset about it. So what I'm asking is, if what I want for Christmas is identical to what I got for Christmas, we're going to log a console message that says, "Yay, the little children are so pleased," and set whether they will cry about it to false, which it already was. If it's anything else, I'm going to log a message that says, "Oh no, sad Christmas," and set that we will cry about it to true. Now here's the new part. In a normal if statement that we've seen so far, like this first one, we have a full expression that then evaluates down to true or false. We can also just check a single variable in the same way. So we can say, is this variable true, or rather truthy? Just writing the variable name in here is enough. I say truthy because JavaScript doesn't just interpret the Boolean true as true. Almost any non-empty value will be interpreted as true for this purpose. Let me copy in another block here. Copy and paste this. Likewise, if we wanted to check whether it was false or falsy, we could put the not in front of it like this. Of course, if I'm checking whether to not cry about it, the child will say something happier like, "Yay." So you will often see entire expressions that can be expressed in a single variable collapse down like this in JavaScript code, and you can feel free to do it this way yourself. Let's execute this entire block now. So what we wanted for Christmas was a puppy, and what we got was a puppy. So that meant that this first block executed, and the children were so pleased. We skipped this, came down here, cry about it was set to false, so the children said yay. Now let's change what we got for Christmas to, say, a fish. And execute that entire block without the variable assignments again. So this time we get the opposite. Oh no, sad Christmas, and the children cried. Because cry about it was set to true, and that's a truthy value. The Mozilla Network has a glossary defining what JavaScript interprets as truthy and falsy. For maximum clarity, you can stick to conditions involving strict equality, like these, or inequality, of course. But these short forms work and are very much in popular usage. Let's look at one more thing, the ternary operator, or the conditional operator. I'm going to copy this block into the browser. Paste it in. The ternary operator is an expression followed by a question mark, followed by an action to take if this condition is true. Then there's a colon and the action to take if the expression is false. So let's execute this. The animal was a cat. So then we checked, is animal a cat? And if so, we executed this first line. And it says you will be a cat herder. If we change animal to a dog, now we will be a dog catcher. The ternary operator is pretty terse, and remembering which order the colon and the question mark can go in is a little tricky at first. I avoided it myself for a while, but at this point I've gotten used to it and started using it more. In this video, we'll look at one more, quite terse, if construct, which is called the ternary operator, or the conditional operator. I'm going to copy this block and bring it over into Chrome. So this is that conditional operator in action. It's an expression, followed by a question mark, followed by some other expression, which is what you want to happen when this expression is true, then a colon, and what you want to happen when this is false. Let's try executing this. Because the animal is a cat, I check whether it was true, and if so, I do what appears between the question mark and the colon. If the animal were a dog, I would do what appears after the colon, ignoring what's in between the question mark and the colon. The ternary operator is often used to set a variable based on certain conditions. Here's a line that does that. We're going to copy the whole thing and bring it over. So having executed this, animal is a cat. Here's my console message right here from this first block. And then I set the job variable based on the same condition pretty much. The job right now is cat herder. So if I change animal to dog, and I reassign the job variable, now I get dog catcher. The ternary operator is pretty terse, and remembering which order the question mark and the colon go in can be a little tricky at first. I know I avoided it myself for a while, but at this point I've gotten used to it and have started using it more often. You can add parentheses to this to help make it a little clearer. So I'm going to type an up arrow. I could add parentheses here. This really makes it obvious that I'm checking a condition here before trying these other actions. I could even add parentheses around these if I wanted to. Adding parentheses to surround expressions like this, if there's no order of operations to care about, can really enhance readability. But as with anything in any kind of programming, there's always a trade-off between terseness and readability. But all these terse if statements, one-liners, one-variable conditions, and now these ternaries, are very common in the wild. And you may decide that you want to use them in your code as well. At this point, we're aware of many data types in JavaScript. We know about numbers, strings, Booleans, objects, arrays, and so forth. There will be times in JavaScript where you want to find out what a variable contains, what type of data it contains. We're going to look at that in this lesson. JavaScript doesn't care about data types to the same extent that some languages do. In other words, it's loosely typed. There's a video about strongly versus loosely typed languages later in this course, but for now, just know that JavaScript lets you do what you want with variables. So I've made this variable called thing, and I've put the number 12 into it. But if I decide later I want to change thing to a string, that's fine. I can do that. JavaScript doesn't care at all. During the execution of a program, there will be many times when you're dealing with uncertainty. You can get to a variable in a particular portion of your program and you don't necessarily know what's in there. And before you act on that data, you might need to check what type it is to make sure that anything that happens afterwards is something you can actually do. You need to check the data type. To do that, JavaScript offers the typeOf operator. It looks like this. TypeOf, all lowercase, one word, and then the variable that I want to check. So we'll say thing in this case. It currently has a string in it, so I would expect to get back string, and indeed, that's what I get down here. TypeOf always returns a string. It isn't always the word string, but it is a string with the name of the data type in all lowercase. So if I set thing back to the number 12, typeOf thing will give me back number. I'll hit the up arrow a couple of times, and we'll reset thing to false. Run typeOf again, and now I get a Boolean. If I reset thing to an empty object and try typeOf, I get object. All this is exactly what we would expect. But now let's try something else. Let's change thing to an empty array. I'll try typeOf again. It still gives me object. Now we know that technically JavaScript arrays are objects, but there are differences that can be important to us. So if we want a way to know whether thing really is an array, we have to do something that's a little bit different than simply using typeOf. We can check if the type is object, and then use a method that all objects have called hasOwnProperty. So I'm going to put in an and here, and the browser is completing all these methods for me, which is nice. I can just hit a right arrow to expand that out. I'll add on some parentheses, and now I need to pass in the name of the property that I want to see if thing has. Arrays are objects that also have the property of length. That's not the only thing that differentiates them, but it's a convenient thing to check. So if I want to know if this is an array, I can check whether thing has own property length. This entire expression will tell me whether thing is an array. Let's try changing thing back to an object. I'm going to hit up arrow a few times to get back to that. And let's confirm that I get back the correct answer here. I'm expecting that this expression should now return false, because this is an empty object that shouldn't have the property of length. There we go. I can see it comes back false. There are other instances where type of will not return something as you might expect it to. So, for example, we know that there's a thing in JavaScript called not a number, spelled like that. It's called not a number, so if I check what it is with type of, what do I get back? Number. That's a little counterintuitive. So if you're doing some mathematical work and you want to see if your result is not a number, using type of on not a number is not the way to do that. The built-in number object that JavaScript has a method called isNan that you can use on your variables to check whether they have actually turned into not a number. Likewise, we can do type of null. We get back object, which is a little weird. So if we want to check whether a variable is null, we're really better off using a strict equality operator. So let me set thing to null. And what I'd really want to do is check is thing null, which in this case is true. Set thing to not a number and check whether thing is strictly null and it come back false. So that'll work a lot better when you're wanting to check whether something is null. With type checking, there are many subtleties that you'll run into with different special values in JavaScript that won't necessarily give you back the answer you expect. So you need to be careful with it, but it's still useful for doing basic type checking. If you need or want to get more serious about type checking in your JavaScript code, you might consider using helper functions from popular libraries like Lodash, which includes functions like isNumber, and lots of others that can check for the type of data in a way that's a little more robust than JavaScript by itself. Or you could even consider using TypeScript, which we'll talk about later. But that's well past where we are right now. Just know that basic type checking is included in JavaScript, and there are options out there for more if you need them. When we talk about programming computers, it's always with the goal of making the machine do something that maybe we're not so good at, or maybe we just don't want to. One of the things that a computer can do really well is the same thing over and over again. So what I'm talking about is called looping. In this lesson, we're going to talk about for loops. Specifically, we're going to talk about sequential for loops. This is a way of telling the machine to do something over and over and over again a certain number of times. And it looks like this. You write the word for, and then, in some parentheses, you'll put 3 statements, followed by a curly brace. What we're planning to do here is something 10 times. And the first thing I'm going to do is initialize a variable. It's kind of a convention in for loops to use I, which stands for index, and set it to 0. But what this is called and what value you set it to are completely up to you and the requirements of the program that you're writing. Then we add a semicolon. So that's the initialization. The next part is when to stop. So if we're starting I at 0 and we want this to execute 10 times, we want I to be less than 10. I could have phrased this as 1 and I is less than or equal to 10. It seems a little bit more common to use 0 and then using less than instead of a less than or equal to here. But again, stylistically, it's up to you. That is also followed by a semicolon. So we have our initialization and our ending condition, but how do we get from there to there? Every time through this loop, we're going to increment by 1. There are different ways that you can phrase this, of course. We're going to use the plus equals 1 version here, but you'll also see it very commonly expressed as I++. Okay, and then comes our curly brace. I'm going to hit Shift and return a couple of times and add a closing curly brace. And in between those curly braces, we put whatever we want to happen every time this loop runs. In this case, we'll do something simple. We'll just log a console message. And we'll send the current value of I each time through the loop to the console. So just to recap, what we're doing here is we're initializing a variable to 0. We're incrementing it by 1 every time through and stopping when it is no longer less than 10. So this should execute 10 times. Let's try it. So it goes from 0 through 9 for a total of 10 executions. Great. Now, of course, you can have as much stuff as you need inside these curly braces, not just one line and not something just this simple. Let's take a look at another example loop that's a little more like something you might use in the real world. I'm looking at this whole thing here. A very common use case for for loops is to loop over the contents of an array. So here we have an array of page names, home, about us, and so forth. 6 items total. Now, in the real world, we might come up with some clever way of populating this page titles array instead of writing them in statically like this, which is called hard coding. But for now, this will work. So we have this array of page names, and now we're going to look at a piece of code that will go through this array and tell us when we've found the one that we're on. To do this on a web page in a browser, we'd be accessing the document object that web browsers provide us through something called the Document Object Model, or DOM, which is the interface that a web browser provides JavaScript developers for interacting with what's on the page. The document object has a property called title, which is the contents of the title tag on that page. So here's what we're doing with our for loop. We're starting out at 0 again, and we're stopping when we get to the length of the page names array here. So we're checking pagenames.length instead of just saying 6 or whatever. If the length of this array changes, this piece of code does not have to. And then we're incrementing by 1, just like we did before. So the first time that this loop executes, we're going to be checking page names sub 0, which is home. And if we were on the home page, this would execute, and if not, this one would execute, and so on and so forth, all the way through all of these. So let's actually try this and see how it works. I'm going to copy this whole thing and switch back to my browser. To do this, we're going to need an actual page to execute it against. So what I'm going to do is switch over to this tab where I've loaded the sandbox.html file from the exercise files for this video. Now I'm going to use Command-Option-I to open up my developer tools and switch to my JavaScript console. You can see here's my tiny little page over here. This is basically just a little stub file. It doesn't have anything really meaningful in it, except that once it's loaded, I do have access to the document object model, including the page title that I can use through document.title. So this current page is JavaScript Playground, as you can see up here in this tab. So let's paste in this code and execute it to see what happens. So there we go. We are not at any of these other places, but we are here on the JavaScript Playground. I went through each of these items in the array in turn because of the way this was constructed. And then my if statements executed this one or this one, depending on where we were. If I wanted to stop after I found the page that we're on, I'll bring this whole block back. I'm going to hit Shift Return here, and I could add a break to this if block, just the way we do with switches. Only in this case, it'll break the for loop. So let me hit Return and execute that. Once we got to the JavaScript Playground this time, the loop stopped. That's called short-circuiting a loop. One more quick note about this code. You can see that I have page names sub I reused 3 times in this little block. We could rewrite this to use a variable instead, which makes it more obvious what we're doing each time. Instead of page name sub I, we could say, okay, yeah, this is the current page title. So we're checking whether document.title is the current page title from this array. That just makes it a little more obvious and a little more readable when we're looking through our loops. So that's a look at sequential for loops, which do the same thing over and over again. In this video, we're going to look at another type of for loop, the enumerative for loop. This is one that you can use on arrays or objects, and it's very useful, but you may need to be a little careful with it. So here I have a couple of code samples. First, we'll look at iterating over an array with this thing. I have a variable called page names. It's an array with 6 items. Now to iterate over this using the techniques we already know, I could use a for loop where I'm setting I to 0, going up to the length of the page names array, and incrementing every time I go. There's another way to do this that uses the enumerative for loop. This is what it looks like. We start out with 4, followed by parentheses again, and I'm initializing a variable, but instead of doing all the other stuff where I'm setting an upper bound and incrementing or decrementing or however it is that I need to traverse that item, I'm just using the keyword in and then the name of the array. Each time through this loop, the variable p gets set to a different key from this array. With an array, the keys are numbers, and I'm expecting p to get set to a number each time for as many of them as there are. Now you'll notice I'm not saying anything about order. This is a caveat. The order is not guaranteed by the JavaScript specification when you're dealing with a for in loop like this. In my experience, you do tend to get the keys back in a sensible order with arrays. We just can't depend on it. This is shorter and maybe a little more pleasant to read than a sequential for loop, but if the order of the original array items matters for your for loop, you can't trust these for in loops exactly. So let's copy all this code in switch back to the browser, paste it in, and try it. And so here I go. I have all of my keys, 0 through 5, because there are 6 items in here, and the names. Notice that my console.log here passed 2 items with a comma in between them. The console log function can take as many arguments as you want to pass to it, and just prints them out like this. So 0 is home, 1 is about us, and so forth. Like I said, often with arrays, a sequential for loop is more reliable, but you might see this in other folks' code, so I wanted you to see what it looks like. A for in loop can also be used on an object in a way that's harder to do with sequential for loops. So here's a page's object with various properties. I've just used ordinal words here, and then names. Down here, I have my for in loop that goes with it. I'm using a variable named p again, and this time I'm in pages. We're going to skip this line for a second, and it basically does the same thing. Just iterates over all of the keys that are in this array. So each time through, p is going to be set to first, second, third, and fourth, and then I'm using that to access that property inside the pages object. Let's copy this one and try it. Clear this, paste it in. There we go. Here are all my keys, first, second, third, fourth, and fifth, and all the page names that go with them. Now again, you cannot plan on these keys being in the order that you set them in the original object. That's very important. If the order of the keys matters, you should probably use an array and use a sequential for loop. All right, now let's go back and look at this loop a little more thoroughly. Specifically this line here, where I'm checking if pages has own property p. So what I'm asking is, does this object, pages, have its own, that is, an uninherited property called whatever p is, which would be first, second, third, and so on, each time through the loop? Without going too far into the weeds, JavaScript is an object-oriented language that uses a model called prototypal inheritance. There's a video about that later in this course, but for our purposes right now, it means that the language can be modified very deeply. And an object like this, an object that you created, could have inherited properties that other parts of the code that's active have inserted. And those could potentially show up when you try to enumerate it using a loop like this. Using has own property is your way of safeguarding yourself against enumerating over things that you didn't mean to. As I say, the details of this are a little on the esoteric side, and there's certainly a lot of code out there where you won't run into this problem at all. But if you're going to be enumerating over an object using a for in loop, it's pretty important to include this check. So just file that away and know that it's something to look for. And if you ever do see it in someone else's code, you'll know what it means. So that is how you can use enumerative for loops to iterate over an object or even an array. In this video, we're going to talk about one more kind of loop called the while loop. To set up a comparison, let's look at a for loop first. This is the sequential for loop we've seen before, where we have an initialized variable, some bound where it should stop, and the way that we get to that bound. And then inside the curly braces, we take some actions. This is the same thing expressed as a for loop. I'm initializing a variable, and then I have the keyword while, and then in the parentheses is my terminating condition. And then inside these curly braces, this will keep happening over and over again, whatever's in here, until I reach this terminating condition. And to make sure I reach it, I include my incrementing inside the curly braces. These two loops do exactly the same thing. I'm going to copy this over into my browser just to prove that it works. So there we go, 0 through 9, just like we would have done with that for loop. So this might raise the question, why would you use a while loop when you could just use a for loop, or vice versa even? The primary reason you might use a while loop, other than just maybe you like to write things in a certain way, is when you don't know how many times you're going to need to loop over something. You don't have a particular object over which you're going to iterate a certain number of times, or you don't have a particular counter where you know the endpoint. So here's an example of that. I have an array, it's called myArray, and it's full of Booleans. Now, of course, I just made this, so I know what's in it, but there will be many, many times, as I've said before in your programs, where you won't necessarily know at any particular time during a program's execution what the contents of a given variable might be. So let's pretend I don't know what's in my array. I have a variable called myItem here, and here is my while loop. My item starts as null. So my condition is that as long as my item is not strictly equal to false, do some stuff here in the curly braces. And that stuff is, first I'm logging a message to the console, the state of my array, how long it is, and then it will loop over and over again until we pop a false value off of this array. So I'm checking the value of my item each time, and as long as it's not equal to false, I'm going to keep going. So just to walk through how this would work, the first time my item is null, not false, so I do what's in here and finish by popping off a value from my array. The first time I do that, it's true, so I go again through the loop, pop again, we get another true, we go again, pop one more time, and this time I get false. So when I check it here, this condition evaluates to false because my item is false this time, and so the statements inside the braces don't execute. If we did this with a for loop that's based on how long the array is, we'd still get that false value, but we'd go until we exhausted the whole thing, unless we included a break statement. But a while loop can express this idea a little more clearly. So let's copy this whole thing to the browser and try it. So there we go. My array had 6 items. Then we popped off true. Had 5. We popped off true again. There were 4 items left, and then we stopped. This is really good in situations where you don't know the contents of whatever the thing is that you're going to loop over, and you have a condition where you're sure you're going to be able to break at some point. Here's the danger with while loops, really with any loop, but I think it's a particular danger with while loops, is that it's easy to create what's called an infinite loop. That is, one that never breaks or stops. Here's a really contrived example of an infinite loop. So I have a counter here set to 1, and then my condition here in my while loop is true. And I have nothing else here, it's just true, which is the truthiest value there is. So this will always be true, and it'll just keep going and keep going and keep going, counting and counting and counting. Fortunately, I have a break statement in here. So if I were to really execute this right now, it would only go through once and stop. But if I took out this break, or commented it out, and tried executing this in a browser, it would just go nuts. It would just print out numbers until there was nothing to print anymore. Your machine, or at least your browser, might run out of memory, or at least your browser might say, hey, your script is running away, would you like to abort it? Thankfully, with modern computers, we don't have to worry so much about infinite loops taking down the entire system, but it's still something you want to watch out for because it's certainly a pain to debug these. Okay, there's one more formulation of the while loop that I'd like to show you, which is called the do while loop. So my item is false here, and we're going to skip over this for a second and just look at the while part, which says, do stuff if my item is not false. So with a normal while loop under these conditions, nothing inside the curly braces would execute. It would just be skipped over. A do block before your while guarantees that what's in the curly braces will be executed at least once, no matter what. And then the condition is checked and the while loop takes over. So if there's a situation where you're writing a while loop and you want to make sure that everything in the curly braces is executed at least once, you need to use a do while loop instead of a regular while loop. Now you've seen the while loop and the do while loop. Yet another way of iterating in JavaScript. Use it with caution because sometimes you can create an infinite loop without meaning to, but it's a great way to do some looping when you don't know how many times you're going to need to execute that loop. In this video, we're going to begin looking at functions, which are a way of packaging up lines of code into one unit that you can name, invoke, and maintain separately. We've been dancing around the idea of functions a little bit in this course. It's kind of difficult to talk about anything in JavaScript that's meaningful without touching functions at least a little bit, so I'm glad we've gotten to it at last. Anytime I've talked about methods that are part of objects, those have been functions. And now it's time to talk about making our own. We're going to start out with these 4 lines of code here. Just 4 lines of console.log that make animal noises. Really mission-critical stuff. Of course, if I'm going to do this repeatedly in real time, if I take this over to the browser console and paste it in, it's easy enough to do things over and over again. I can just hit the up arrow and I get it back, hit return, and it goes. As many times as I might want to do this, I can just do it over and over again manually. If I'm writing a JavaScript file, I could just copy and paste the same thing over and over again. But if I ever need to change how it's implemented, say, make the first one not arf, but nay, or whatever, I would have to go back and change each instance of that in my code, and that's tedious. What we would do in that case is define a function, which would wrap all these lines into a single unit that I can name and then use whenever I needed to. And if I need to change it, I just have one place where I would make that change. So here's how we'd do that. Here's what a function is at its most basic. You simply write the word function, then a space, and then the name of the function. Next, a pair of parentheses and a curly brace. You have another curly brace to end it, and then inside those curly braces, you just put the lines of code that comprise the function. In this case, we've put our animal noises into a function called speak. And if I copy this and bring it over to my console, I'll paste it in, hit return. Now I have this function defined. It's called speak. And now to actually make these lines execute in the context of that function, what we do is called invoking the function, which is to write out its name, speak, followed by the two parentheses and a semicolon. There we go. So now instead of writing those 4 lines out, if I wanted to do this again, I can just use my one line, speak. As we'll see in upcoming lessons, this is not nearly everything you can do with functions. But even if it were, this by itself would be pretty useful. Functions at their most basic can tie together lines of code and give you one executable unit that has its own name and can be executed as many times as you need. Really quite useful. In this video, we're going to extend our knowledge of functions by looking at using arguments to solve a couple of different kinds of problems. One is to take some data and modify it. The other is to get the answer to a question in a way we'll need to use repeatedly. So we'll start out by looking at modifying some data. Let's say I want to be able to take any string and change it so it looked like it was being said by Elmer Fudd from the Bugs Bunny cartoons. I have a function called fuddify that will do this. Let's see. How about be very quiet, I'm hunting rabbits. And it comes back with be very quiet, I'm hunting wabbits. Okay. I could put in any string, like, how about you screwy rabbit? You squooey wabbit. Yep. So by having this function, I don't have to write the lines of code that would do the processing on these strings over and over again. All I need to do is invoke the function and pass it all the different strings I want. So, how does it work? Let's take a look at the definition of this fuddify function. Here it is. I have the word function followed by fuddify, and then here inside the parentheses, I have speech. This is called an argument or a parameter, and it's just a variable that in the context of this function will be known without my having to define it separately. So I'm passing in a string, which will be named speech. At least a string is what I want, so the first line inside the function, the one that's not a comment, checks to make sure that this is actually a string, using type of. And if it isn't, it logs an error message, says, nice twy, wabbit, and returns. Return short-circuits the rest of this function. If this line executes, the rest of the function body down below is ignored. But assuming speech is a string, we process it by making some changes to it, and then returning it. Because we're using the JavaScript console, the return will just be shown right in the console unless I capture it somehow, like say in a variable, like this. Switch back over to the browser and try this. So now because I've captured the output, it doesn't get returned directly. It goes into this variable called utterance. So that's how you can take data and process it using a function. The other main case for which you'll be using functions at the beginning would be to answer a question that you need the answer to over and over again. So, for example, we know that we can determine whether a number is odd or even using the modulus operator. So 12 mod 2 returns 0, and that's how we know that the number is even. But using that expression directly doesn't really illustrate clearly what we're trying to do. It's much better to create a function that's named something meaningful, same as with variables. In this case, what I'm doing is checking whether a number is odd or even, so I could define a function called isEven that returns true for even numbers, false for odds. Here's what that could look like. So here's how I've defined isEven. I have function, and then the name of the function is even, and it takes the one argument, num, and then I'm asking, is this number, mod 2, equal to 0? In other words, is the remainder 0? In other words, is the number even? And if so, I return true. Otherwise, it's an odd number, so I'll return false. And when you have a really simple comparison like this that either returns true or false, you can collapse this whole thing down even more by returning this value directly. Because as we know, a comparison like this evaluates down to true or false. So this one line is equivalent to this 5 lines. In either case, this is very simple, but being able to read clearly named functions instead of mathematical expressions is very nice. My general guidance is don't be shy about creating lots of functions. There are some programmers who have nearly every single line of code they write wrapped in a function. How deep into it you go is, like so many things, personal preference. Now we've seen 2 ways that functions can come in immediately handy when you're working with your JavaScript. One is to process data and return back the modified version, and the other is to package up a way to ask a question and get back an answer to it over and over again. In this video, we're going to look at arguments and functions a little more and see how you can have functions with variable numbers of arguments and how you can provide default values for arguments that you want to be optional. First, I'm going to show this function that I've defined called speakSomething. And it takes 2 arguments. Your functions don't have to have only 1 argument. They can have as many as you want. So anyway, speakSomething takes 2. It takes what to say. We'll pass in hey, hey. And how many times to say it. We'll go with 5. And so when I call this, it says hey, hey, and it tells me how many times it's said it so far, starting with 0. So you can see this works fine. You can have more than 1 argument in your functions. But what if, say, you want to provide default values for some of these? So what if I know that I want to say hey, hey, but I don't care how many times I said it? I can let the function do that for me. And that works fine. In this case, the default value is 10, so it goes 10 times. I can even do it with no arguments. And it just says default speech. So how do we do this with JavaScript? Here's the definition of the speakSomething function. I have the argument what and the other argument how many. We're going to talk about how to set defaults for these. In some programming languages, there are ways to specify default values right here where you specify the parameters, usually phrased something like this. Now, in some programming languages, there are ways to specify default values right here where you specify the parameters. And now in ECMAScript 2015, JavaScript can do that too. But for the greatest compatibility, let's see another way. So here what I'm doing is using the ternary operator. And the condition that I'm checking against is what type what is this argument. And if I haven't passed a value for the parameter, its type will be undefined. So what I'm doing here is checking whether what is not undefined. And if that's true, I use the value of what and set it to this variable inside my function called what. If it is undefined, I provide my default value, default speech. And I do the same thing for the how many parameter, with its default value being 10. And then, of course, I have my for loop down here that does the printing to the console. Now, when you do your default arguments this way, the order of them matters. So I can't just say speakSomething and pass in 10. Well, actually, I can, but that only works if I meant to print out 10 times. If I meant for this to be the number of times that this thing were printed, it's not working the way I would expect. 10 will always be used as the first argument if it's the only one. So you can provide default values, but the order still matters. There are more advanced techniques for defining functions that can handle arguments in different orders and quantities, but when you're just starting out, it probably is more likely to turn your brain into a pretzel. So we'll just leave that aside for now. One other thing I'll note is that you'll sometimes see default arguments phrased as these much shorter expressions right here in the comments. This is a little trick you can do with the logical OR argument that assumes a valid argument you're passing into your function will be truthy, because an expression involving the logical OR will return the first value if that value is truthy. It works most of the time and looks very clean, and it's certainly shorter than this. But if falsy values like 0 are allowed as valid arguments, this version would convert those valid arguments into your default values. So watch out for that. Back here in my JavaScript console, you might have seen in that file that I have another function called addingMachine. We're going to try that now. Here it is. And addingMachine can take any number of arguments. It just doesn't care. I can add 1, 2, and 3, and it returns 6. Or I can go totally crazy and add a whole bunch of numbers in here. Make sure they're all filled in. So how does this work? Let's switch back to the editor and check it out. Here's the addingMachine function, and it's making use of an object that every function knows about, arguments, which is an array-like object that gives us some of the tools of an array. Like real arrays, it has a length property that I'm using here. So what I'm doing is I'm using a for loop to iterate over the arguments array and then pick up the number that is each individual argument. And I'm adding it to a running total down here using the addition assignment operator. And of course, I'm also checking to make sure that it's a number before doing that. So to run this down, we initialize the total as 0. Then we loop over the arguments array, grab each number, check its type, see if it's a number, and add it to the total. And once that's all done, return it. So that's how that function works. You can use the arguments array not just to run through everything that's passed in, but you could also pull out individual arguments using their index. So for example, in the speak something function, I have these two arguments, what and how many. And I can still specify them by name up here, but if I wanted to, I could address them in my function as arguments sub 0 and arguments sub 1. That would also work. So now you know that functions can take an arbitrary number of arguments, and you can set default values for them. You can name the arguments, or you can use the arguments array-like object to address them. And you can use a for loop to iterate over the entire arguments array, allowing completely arbitrary numbers of arguments. In this video, we're going to talk about objects and functions, how objects are passed by reference into functions, and what that means. So to start off, let's look at this object. It's called Calvin, and it has this form. Its name is Calvin, its best friend is Hobbs, and its form is human boy. Now, along with this object, I have a function I've written, which is the transmogrifier. And what this does is it takes a Calvin and transforms its form into something else. So let's try running this. So I can see now that the form has been changed into Tyrannosaurus from human boy. Let's look at the definition of this function. And here it is. It accepts a Calvin object, and then we do a little bit of type checking to make sure that the argument is at least something like we expect it to be. When you're writing functions, it's a good idea to make sure that the input that you're accepting into the function is of a structure that you expect. Otherwise, your code could later break down and you'd have a lot of debugging to do. This is especially important if you're writing a function that could accept input directly from a user, not from you, the programmer. But in any case, for now, we're doing fairly simple type checking just to make sure it's an object. If it isn't, we're just bailing out with an error and returning. After that, we're generating a random number between 1 and 5. So what we're doing to generate this random number is we're using the math.random method, which will give you a number between 0 and 1. We're multiplying that times the number of our upper bound, and taking the math.floor of that, which will give you the largest integer that's smaller than whatever you have. So it basically chops off the decimal points. So this will give me a number between 0 and 4, and so I'm adding 1 to it to make sure that my number is between 1 and 5. And then for any of these 5 numbers, I'm using a switch statement here to get a new form for the Calvin to take, and assigning it directly to that argument Calvin that was passed in. Now, something that you should note about this function, if we look down here to the end, is that there's no return statement at the bottom. Why is that? The reason is that the argument being passed in is an object, and objects are passed by reference into functions. That means that the object I've created, this Calvin in this case, has a location in the computer's memory, and when I pass it into a transmogrify function like this, I'm passing in not a copy of the object, but the original object. In a sense, I'm passing in its location in memory specifically. And then my function, right here, these lines that change the form, are actually operating on the original object. So when I executed my transmogrifier function and passed Calvin into it, he started out as a human boy, and then he came out as a Tyrannosaurus. So this whole discussion is important because there may be times where you don't want your original object to be modified, the way this one was. You might want a copy to come back out. So for example, you might instead want a copy to come back out. So you might want to have a version of this where instead of passing a Calvin in like this and getting him back directly, you might want to set up a new Calvin that gets returned from the transmogrifier, leaving the original. I've defined a version of the function that does that as well. So I'm going to create a new Calvin. It starts out as a human boy. And then I have another function called transmogrify copy. Now I'll pass in new Calvin, and I'll assign the result to a new variable called Calvin copy, like this. Now let's check new Calvin. New Calvin is still a human boy, but Calvin copy has turned into a canary. So let's take a look at how this works. Now you can see a lot of the code for these two functions is quite similar. In fact, a lot of it is exactly the same. We're still doing the argument checking, we're still generating a random number, but here in transmogrify copy, I'm saving the form as a variable called new form. And then in my case blocks, instead of modifying the original object directly, I'm just modifying this new form variable. And once we get to the end of the function, instead of not returning anything, I'm returning a new object that has all the same fields copied in, except for form, which becomes the new form. So now I get a totally fresh object, and I don't modify the original one. I'm not changing the reference. Now note that this pass-by reference business is not just for objects that are clearly objects. This principle also applies to arrays, which you may remember are really objects. So if you pass an array into a function and you modify that array, you're modifying the original. Always keep that in mind. That's what passing by reference means. So to sum up, when you're working with functions and objects, just be careful about whether you're passing in and modifying the original, or whether you want to get a copy back instead, and write your functions accordingly to make sure that you're getting back exactly what you want. In this video, we're going to talk about how functions are first-class citizens in JavaScript. Indeed, they're objects that have the power to be invoked. Let's talk about what that means and look a little bit at how useful it can be. Here's a definition of a function called speakSomething. We've seen this kind of construction before. You just use the word function, followed by a space, followed by the name of the function and its definition. And so all this does is just take this what parameter and then log it to the console using a for loop. Written this way, this is called a function expression. I can rewrite this function definition a different way. In this version, I'm creating a variable called speakSomething, and then I'm assigning to that what's called an anonymous function. The function definition inside the curly braces is the same, but you can see here the function, it's just function, followed by the parameters with no name, hence an anonymous function. And for our purposes, these two constructions are basically equivalent, but they illustrate the idea that a function is actually an object. It can be passed around as a value in JavaScript and assigned to variables, as one example. One of the things that makes this interesting is that you can feed functions into other functions as arguments. And why would you want to do that? I'll give you an example. When you're working with JavaScript on the web, there's a global window object available. All global variables are properties of the window object, and there are a bunch of functions that are built into the window object as well. One of them is called setTimeout. It's a function that takes as its first argument a function. What setTimeout does is it sets a timer after which a function will execute. And so for its first argument, it takes that actual function. So in this case, if I want to speak something after a certain time, I'd feed it as the first argument into setTimeout, just like I'm doing here. It doesn't matter which of these ways I've defined speakSomething. I can pass it in either way by its name. Note that I'm not including the parentheses here because I'm not invoking it right now. setTimeout does that for me later on. Then the second parameter is the number of milliseconds after which I want this function to execute. So with 5,000 here, that would be 5 seconds later. If you've ever worked with another programming language, this could look quite interesting. You're actually taking a function and passing it as a value. Functions are all objects in JavaScript. They actually inherit from a global function object, spelled like this. But that's just a technical detail. The important thing to note is that functions are objects and that you can do stuff like this with them. Let's try it out. I'm going to copy all this and bring it over to my browser. Watch what happens. We'll wait 5 seconds. And there it goes. The 10 here is a detail of the way Chrome and some other web inspectors work. If they get the same thing multiple times in the console, it'll just increment a number instead of displaying it a whole bunch of times. Otherwise, your console window would just sort of fill up with junk. So now you can see that you can pass functions into other functions like this. Another thing that you can do with functions is just like how setTimeout itself is defined. It's a member function, or a method, of the window object. You can create your own objects and assign functions as members of those objects. This happens all over the place in JavaScript. That's how all the built-in methods are defined, and you can do it for yourself as well. So here, for example, I can define an object, call it obj, and then I can give it a property called sayHello, and that property can be a function. This is an anonymous function here, and it just logs a message to the console saying hello. And then I can invoke this function as a property of my object. Let's copy and try this out as well. There we go, it says hello back. So the key lesson here is that functions are objects and they can be passed around as values, just like any other value in JavaScript. This comes up constantly in modern JavaScript as more developers have come to understand how function-oriented JavaScript really is and started to leverage that power. You may not use it yourself in your initial forays into using JavaScript, but you'll certainly see it in the code other people write. It's time for a brief digression to deal with a little bit of jargon you might hear about. JavaScript is super popular and draws a lot of attention from developers of many skill and experience levels, so knowing where some of this jargon comes from can help you at possibly boring parties. Here, we're going to talk about scope. Scope refers to where variables are defined and what parts of our code can access the variables we define. Often when we talk about scope, we differentiate between global scope and local scope. Global refers to variables that are defined in such a way that they're accessible anywhere. Local means that a variable is accessible in a way that's more limited, perhaps only inside a particular function. One piece of guidance almost every beginning programmer gets is to avoid creating global variables. Global variables are accessible everywhere, which is very convenient, but the global namespace, as it's called, is a resource that's shared among all scripts that are in use at any given time, and there may be a lot of them. Global variables can be accessed and also modified by any piece of code. So your little island that you're working on could have bugs introduced by somebody else's code if you're both trying to use a global variable with the same name. Unfortunately, in JavaScript, it's kind of easy to create global variables. If I just create a variable like this with no var keyword in front of it, it will always be a global variable. Unless I've enabled strict mode by putting this string at the top of my file, in which case I'll get a warning. But the point is, it's easy to do this accidentally. To avoid creating global variables, we can use the keyword var. This can keep the variable in local scope, about which we'll talk more in the next video. In ECMAScript 2015 and above, there are other keywords that can create locally scoped variables as well. Let and const. You'll see these in modern JavaScript code, and the way they handle scope is a little different from var, but we'll leave that aside for now. They're worth recognizing, but using var is just fine. We'll get into more detail about scope with some code examples next. In this video, we're going to talk about variable scope and how functions relate to it. Here's an example. I have two variables set here. My num is set to 32, and my result is set to success. And then I write a function. It's called randomizer, and it takes a limit as its argument. Inside the function, I create a variable called random number and assign the randomly generated number to it. Then I create another variable, which is called mynum again, just like out here. And I'm assigning that random number to it. Then down here, I'm logging a couple of lines, and finally returning this number. So let's execute this and see what we get. Then we'll discuss it a little more. So I'm going to paste this all in. And now I'll have a variable called mynum set to 32, and my result set to success. Now I'm going to invoke the randomizer function. I'll pass in 10. So this is going to set mynum to a random number between 0 and 10. Now the question is, what exactly is going to happen here? We have a variable called mynum up here, and one inside this function. Are they the same thing? We can see from these messages that apparently they're not. mynum kept its original value of 32 even though the message says it was set to 3. What we're seeing here is a difference in the scope of these two versions of mynum. In common JavaScript, ES5, along with everything else they do, functions create scope. This version of mynum inside the function is its own separate variable, even though it uses the same name, because that name only applies inside the function. If I hadn't used var to define this, I would have been resetting the value of this version on top, which is a global variable because it's not inside a function. If I have another function, in this case I have one called doubleIt, I can reuse the same variable name again as long as I use var. The version inside each function is boxed off from all the other ones. Of course, you might have noticed that the randomizer function also references my result. That variable is not defined inside this function, but because it's a global variable, also known as being in the global scope or global namespace, I can still use it inside my functions. Also note that if I want to refer to the two versions of mynum, the plain version here refers to the local version, and I can reference the global one as a property of window, which in a web browser is the global namespace. In Node, that same namespace is actually called global in all lowercase. Any local variables I create inside a function are inaccessible outside the context of the function. So even after executing randomizer, any variables that were created inside, like random number, I get a reference error here. It's not available in the global namespace. Functions are the main delimiters of scope in JavaScript classically, but with ECMAScript 2015, the let and const keywords let you create variables that are scoped to any block, not just functions. We're mainly concerned with functions right now, but that's something you can investigate later if you're curious, or as you start to learn more about newer versions of JavaScript. And that concludes our look at the interplay of scope and functions in JavaScript. In this video, we're going to talk about callback functions. We've seen these in use a couple of times, but I want to give them a little more specific attention because they're used a lot in modern JavaScript. Callback function is a piece of jargon referring to a function that's passed as an argument into another function and executed in that function. Because functions are first-class citizens in JavaScript, you'll see this all over the place. Here's a function called doubleIt, which takes a number and returns it, multiplied by 2 using the multiply assignment operator. And here's another variable called myNumbers with the digits 1 through 5 in it. Then here's a variable called myNumbers with an array with the digits from 1 to 5 in it. JavaScript arrays have a method called map that takes a callback, with that callback having one required specified parameter, the item in the array that we're acting on. The callback is executed on every item in the array in turn, creating a new array with the result of each execution. Here I've made an array of all the same numbers with each one doubled using array.map and passing in doubleIt as my callback. As long as the callback has its arguments set up correctly, this works great. So let's select all this, copy it. I'm going to bring it over to my browser, paste it in, and try it. So my numbers is still set to 1, 2, 3, 4, 5, but my doubles is set to 2, 4, 6, 8, 10. So this map function took another function as its argument, a callback, and it executed it on each one of these numbers, creating a new array. Array map is used a lot in modern JavaScript frameworks like React for rendering lists of items in a user interface. Another example of an array method that takes a callback function is forEach. ForEach doesn't return anything. It just iterates over the array, passing each value from the array as the argument into that callback function. It's a shorter way, perhaps a more expressive way even, of looping over an array than a for loop. It's not as easy to stop as a for loop. The break keyword we can use to stop a for loop doesn't do it, but you might find it more pleasant to use, as long as you definitely want to loop through the entire array. In this example here, I'm using an anonymous callback function inserted directly as the argument, instead of defining it in advance. This will log the value of each item in the array without stopping for a break. Let's copy that and try it. There it goes. One other thing I'll mention about callbacks. In ECMAScript 2015, there's another kind of function called an arrow function that you'll see sometimes. Here's the same doubleIt function as up here, rewritten as an arrow function. As you can see, it removes a lot of boilerplate from the function definition, stripping it down to its essentials. The parameters, you can leave off the parentheses that we use up here if there's only one. Then an arrow, and what the function returns. You can leave off the curly braces if it's very simple like this. The parentheses are also optional, but they help clarify what's going on. Because it's so short, it can be popular for writing callbacks for functions like ArrayMap, forEach, and others that can take a function as a parameter. But because it's a feature of ES6, it's not something that's really safe to use in browsers right now. But it is safe to use in recent versions of Node. So that's another look at callback functions and some of the ways that they are used commonly. In the next several videos, we're going to talk about some pieces of JavaScript that are more on the advanced side, but that I think are important enough to introduce conceptually. In this video, we're going to talk about the term asynchronous. When we think about giving instructions to a computer, we generally think linearly. Here's step 1, followed by step 2, and so forth. We don't move on to step 2 until step 1 is finished. This is easy to follow conceptually, and a lot of code that we write follows this mode of thinking, which is all fine and good. Code written this way is said to be synchronous, with every step blocking the ones that come after it. Step 3 doesn't run until step 2 is totally finished, and so on. But what if, say, step 4 is a step that takes a while, and involves waiting for something that steps 5 and after don't need right away? In order for the entire task to be complete, step 4 does need to be finished, but it doesn't need to be finished before step 5 can start. If we're baking a cake, for example, we need to get the cake in the oven so it can bake, but we don't have to wait for the cake to be finished before we can make the frosting. We need the cake and the frosting to be finished and cooled before we can put them together and call the whole job done. But if we waited for the cake to be baked and cooled before we even started the frosting, everything would just take a lot longer. Code involving steps that can run at the same time with the results of some steps coming in later is called asynchronous, because some steps can be run in a way that doesn't block the others. Eventually, the results will all be needed, just not immediately, so we can let other steps happen while waiting for the stuff that takes a while. In JavaScript, the main area where asynchronous code comes up is when we need to load data from somewhere, usually somewhere on the internet. This could be loading some inventory data from a store's back office, a photo from the Instagram API, anything where our code needs to make a request. If you're using Node, loading files from disk is an asynchronous operation by default because disks can be slow. We always assume that the network or other sources of data can be slow sometimes, and if all the code on a page had to wait for that data to load, everything would feel slow and unresponsive, which is bad. As you start writing intermediate to advanced JavaScript code, you will almost certainly need to deal with various ways of writing asynchronous code. In the next video, we'll look at some examples. In this video, we're going to look at what various approaches to writing asynchronous code look like, so you'll recognize the approaches in the wild. We'll look at using callbacks, promises, and the new async and await keywords. So here's some example code that shows these three approaches. The first one here uses the get method from the jQuery JavaScript library, which is a function that takes the URL as its first parameter, and a callback function as its second. That callback gets the response from the server in its argument here, which you can then act on in the body of this callback function. These URLs are to HTTP bin, a real website that provides an API for testing just this sort of code. This works fine for a single call, but if there's another request that depends on the first one and maybe more after that, you get something that looks like this, where you end up having to nest all these callback functions within one another, and it gets to be a bit of a mess to write, and it can get hard to understand if these functions get at all long. Programmers call this kind of thing callback hell. Scrolling down, we have some examples of promises. Promises are a much more pleasant way to work. Promises are objects that capture the result of an asynchronous action with a particular programming interface, or API, for handling when the promised data successfully came through or failed for some reason. Axios is a popular library for making network requests and returning promises, and it looks like this. This looks a lot like the jQuery version in that there's a get method, but the way it's handled is different. I make the request, and then instead of a callback passed in as a second argument, I directly chain on a method called then, which is part of the promise specification, and that contains the callback where my data comes back. This works because Axios' get method, and pretty much all of the methods in Axios, return a promise, and promises have a method called then available. If, once I'm inside that then function, I need to make another request, I just return another promise like this, allowing me to chain on another then method at the same level as the first one. I know this might sound like a lot right now, but the point is that this is how most of the better code involving network requests is written, and I want you to be able to recognize it when you see it. This whole business of then followed by a return, then followed by a return, and so on. Browser support for promises isn't perfect, but there are JavaScript libraries we can add on to our projects to polyfill or patch in support for the parts of the promise spec that your older browser of interest doesn't support out of the box. And then finally, there's async and await, which are part of the ECMAScript 2017 specification. These make working with promises even easier to read. Functions are marked as asynchronous with the async keyword. And then network requests can have their return values stored directly instead of being handled inside a callback function using await before that promise. This can really shorten code that makes a lot of network requests, like this getLotsOfThings function here. Instead of having anything nested or chained, I just mark each promise with an await, so I can just get the response as soon as they're ready. This is all relatively new, and many developers are still coming to grips with how it works, but many browsers and the current version of Node all support this, so it's worth being aware of. So now you've seen some examples of asynchronous JavaScript in the form of old-school callbacks, regular promises, and the new async and await. In this video, we're going to talk briefly about object-oriented JavaScript, because the term object-oriented appears often in programming, so it's good to have a bit of exposure to it and what it means for JavaScript. We've seen JavaScript objects already. They're a generic way of bundling up data that belong together. When we talk about object-oriented programming, we're talking about the same thing, but particularly at a conceptual level, being able to reuse code by setting a template for a type of data, and then every time I need to use it, getting an instance of that template. Different languages handle this concept in different ways, especially in the way objects can be related to one another. Say I want to make a cake template, which has some features like the number of layers, the primary flavor like chocolate, vanilla, or lemon, and some functions like bake and cool, all things that any cake is going to need. Anytime I want to make a cake programmatically, I could just get an instance of my cake object and be off to a good start, just writing the code for whatever features are unique to that instance. If I'm going to make a lot of, say, chocolate cakes, I might want an object called chocolate cake that inherits the shared features of the base cake, but has its own features that are more specific than the original cake, but still general enough to be reusable among all chocolate cakes, like making its primary flavor chocolate by default, so I don't have to set it every time. This relationship between chocolate cake and cake is called inheritance, and the way inheritance works is central to any object-oriented language. So the question is, what mechanism is used to relate these objects? The way JavaScript works is different from most other popular languages. It uses a model called prototypal inheritance, where every object has a link to a parent object from which it inherited some data and functions, and that parent has the same link to its parent, and so on. These links are called _proto internally and comprise what's called the prototype chain. This topic is one that's worth looking into in more detail as you become a more proficient developer, but in terms of our goal of making you conversant and recognizing common code idioms, I want you to recognize something like this. This is how you add a method to an object using its prototype, which makes it available to all objects that use that prototype, wherever they are down the prototype chain. Newer versions of JavaScript add some keywords that make JavaScript's prototype stuff look more like what people coming from other languages are used to, like the class keyword. But ultimately, it all gets turned into prototypes eventually. Because these are enhancements to the way the language looks but don't really change how it works underneath, these kinds of additions are called syntactic sugar. There's a lot more to learn about object-oriented JavaScript if you're interested, but this quick overview gave you a few things to look for as you're developing familiarity with the language. Programming languages are categorized in lots of ways, one of which is whether they're strongly or loosely typed. JavaScript is loosely typed, and I want to give you a little information on what that means and why, at some point, you might care. I'm bringing up loose versus strong typing because it comes up with variables. In JavaScript, you've seen that we can create a variable, assign it a number, and then turn right around and assign it to a word or a string later. Being able to reuse variables however you want makes JavaScript very flexible. Very experienced programmers can have strong opinions on whether this is good, but either way, JavaScript is a loosely typed language. In contrast, with a strongly typed language, your variables know about and enforce what kind of data they can store, broadly speaking. The language will trigger some sort of error if you try to, say, put a number where you originally had a string. This can feel constraining, but it can also help avoid bugs, especially in larger programs and applications. Say you have a variable called authorname that will be used later in some way that makes sense for a person's name. If you later assign a number, your program might do something weird later because you fed it a number instead of a string. A strongly typed language tries to help you avoid these problems. One of the most popular solutions to this issue is TypeScript, which is JavaScript but with some extra features added on, like stronger typing. Many large JavaScript projects and frameworks write their original code in TypeScript and transform it into JavaScript for running on the web. So you may see this discussed or become curious about it at some point, and I wanted you to know about it. In this video, we're going to talk about some of the popular tools in the JavaScript ecosystem that help with various tasks. When you're just starting out, you don't need any of this stuff. But if you want to get into JavaScript professionally at some point, I want you to know about these tools so you can start exploring them in more detail. JavaScript powers so many things on the web and elsewhere. Some projects are enormous, involving millions of lines of code, and are handled by teams of dozens or hundreds of people. Open source JavaScript projects can have contributors of many experience levels, all over the world. With the continual maturation and proliferation of JavaScript, it was inevitable that developers would start writing tools to help solve various issues that come up. One issue is how to handle JavaScript libraries and modules. As projects grow, it makes sense to start splitting files up into smaller ones that contain related code. In an object-oriented project, there could be files for each type or class of object, or just a file containing all the helper functions you've written. Once you've broken them up, you need a way to load the ones you need. Browsers load scripts with script tags, but managing those manually can be a pain. What if script A doesn't work without script B having been loaded first? Oh, and by the way, what if script B needs script N before it? And so on and so on. Until recently, there was no official specification for how to load shared JavaScript libraries. That specification exists now. It's called dynamic imports. But browser support isn't very good right now, and the problem has been around much longer than the specification has existed, so tools have been written to handle this. The most popular ones are probably Webpack and Rollup. Module loading is just a small part of what these tools can do. Both have plugins that can handle lots of other tasks, like minifying JavaScript, which removes comments and whitespace for faster downloads, and tons more. There are videos and courses available on both these tools. There are also tools called package managers for managing the installation of JavaScript libraries. If that doesn't sound important to you, think about a simple example, installing a jQuery slideshow plugin. If you don't already have jQuery, you'll need that, and then the slideshow plugin, and then maybe you need a plugin to support touch input for mobile devices. For something small, there's still a lot to download and deal with. To help with this, there exist NPM and Yarn, which handle downloading JavaScript libraries and packages, making sure to install everything you need in a standard folder structure. Webpack and Rollup are aware of those standards as well, making dynamic importing of files installed this way very easy. Learning NPM, the Node package manager, and learning package management with Yarn will tell you a lot more about both of these. One other kind of tool that's used all the time is a transpiler or a compiler. If you want to use ECMAScript 2015 or newer in your projects, or you just want to use TypeScript, you'll need one of these to convert that code into the kind of compatible JavaScript that will run in any browser. Babel is a transpiler that's wildly popular for converting ES6 and other modern JavaScript specs into ECMAScript 5. And TypeScript has its own compiler as well to convert into vanilla JavaScript. Either of these can be integrated with Webpack or Rollup, giving you a one-stop shop for building your finalized JavaScript when working on a larger project. As I said earlier, you don't have to use any of these tools at first. Depending on how you use JavaScript, you might not ever need any of them. But if you work with the language for a while, you might start to notice some friction in your workflow, and tools like this might be able to help.